Rao is one of the foremost voices making the claim that LLMs can't truly reason.
These are essentially n-gram models.
The old stochastic parrot claim.
In general, the creativity part is something that LLMs are extremely good at.
We can make like a Venn diagram, right? Like new knowledge, reasoning, creativity, and like different experts who are granting that AIs do or don't have all of these magical terms. Welcome to Doom Debates. Today, I'm reacting to an episode of Machine Learning Street Talk with Professor Subbarao Kambhampati. This is from a few months ago. I've been meaning to get to it for a while because Rao is one of the foremost voices making the claim that LLMs can't truly reason. So it'll be interesting to dive into exactly why and what kind of examples he can give and how strong I think his argument is. I'm looking forward to listening to the podcast and making a judgment on that. Some background info on Professor Kambhampati. He is a professor of computer science at Arizona State University. He studies fundamental problems in planning and decision-making, motivated in particular by the challenges of human-aware AI systems. He has a PhD in computer science from the University of Maryland, and he's pretty active on Twitter at Rao, RAO2Z. All right, let's dive in.
Okay, so you've said that large language models are n-gram models on steroids, approximate retrieval systems, or maybe even databases, and they can't reason or verify anything that they do out of the box.
Oh boy, here it comes.
Tell us more.
So first of all, I think the large language models, they are trained essentially in this autoregressive fashion to be able to complete the next word, guess the next word.
That's obviously correct that LLMs are trained to complete the next word. But now let's watch Rao make this huge logical leap from LLMs are trained to complete the next word to LLMs are basically just statistical n-gram models. Here we go.
And these are essentially n-gram models. They've been around since the time of Claude Shannon. The difference really is those n-gram models for n equal to 1 or 2 or 3. So we have pretty good understanding of bigram models, trigram models. If I say left and you tend to think of right. And that's sort of the trigram model sort of a thing. What actually is happening here is that we really, even the lowly GPT 3.5 happens to be, sort of a 3,000 gram model. So that means given last 3,000 words, what's the most likely next word? It's the same idea, except on huge steroids.
Yes, the old stochastic parrot claim. He's basically saying, you know how naive AI from 50 years ago is able to just catalog the frequencies of different pairs of words in a text? Well, LLMs also catalog the frequency of like 3,000 word phrases and then somehow match them to other 3,000 word. Long story short, it's just word frequencies, okay? It's just stochastic parrot. So this is super hand-wavy, and he even kind of admits why it's hand-wavy in this next part.
The tricky part about this is the number of 3,000 word sequences. If you have about a 50,000 word vocabulary, is 50,000 power 3,000. And so if you are trying to keep occurrence statistics, which is the normal way to do n-gram models, we run into two problems. One, of course, is this a humongous, set of rows for which you need to have, conditional probability table and what's the next word that's likely to come. And secondly, the other problem is the possibility that the same 3,000 words will occur more than once is essentially zero.
Right, exactly. So the two problems you just pointed out are exactly the reason why you're totally wrong, that these aren't n-gram models, right? So just to review Rao's two problems, because he got them correct. The first problem is, like he said, nobody could realistically build a lookup table where every row in the table has a string of 3,000 words in it, like a 3,000 gram, because 10 to the power of 3,000 or some exponential like that is way too big to fit in the memory of any computer. So that's the first problem. And then the second problem, which is an even bigger problem from my perspective, is you don't see the same 3,000 gram again, right? I'm just repeating what he said. So he's talking about doing statistics in a space where it's not about frequency. It's not about statistics, right? So he just undermined his own claim. But now supposedly he's going to rescue his own claim and make it make sense again. Make it make sense, Rao.
So the thing that's surprising about LLMs basically is we essentially have are able to train these really large beasts, and there's huge amount of compression that goes on. So I tell students that, when you think of GPT 3.5, right, people will be surprised how it has 176 billion parameters. And I think, no, you should actually be so happy that it's only 176 billion, because if you really are trying to do it in the full first principles way, you would wind up having 50,000 power 3,000. That's actually infinity, in some sense.
Okay, so it's somehow a big n-gram statistical model that achieves a compression factor that's larger than the number of atoms in the universe. That seems like such a big compression factor that you're no longer talking about statistics, but go on, explain how it makes sense.
So because there's this huge compression going on, interestingly, any compression corresponds to some generalization, because you compress, so some number of rows for which there would be zeros before, now there might be non-zeros, and so for some words. And so this, what we found empirically is that when you complete with these trained models, they are giving completions that have very interesting properties. In particular, it's a generative, it's a sort of a generative AI system. And so they capture distribution extremely well. And what that means is they capture the style of the data on which they have been trained on. And as English as a second language speaker, I learned English with grammar rules, which kind of almost makes no sense. But that's, your first language, you don't learn grammar, you just learn to speak language. Second language, you tend to follow some rules and exceptions and rules and exceptions. And that's a kind of pretty hard way to learn a language. And I was continually impressed when GPT-3 and GPT 3.5 came around that they can't make a grammatically incorrect sentence.
Okay, hold on. I feel like we're getting lost here. Rao hasn't justified the claim that GPT 3.5 or GPT-4 is only a statistical model that's really not much more than an n-gram model. He's talking about compression, and he's saying, wow, it's so impressive that they've compressed it down to somehow a smaller statistical model, and it speaks English with the right statistical properties. But hold on a second. My competing theory is that it speaks English with good statistical properties because it actually understands English, because it's not an n-gram model, right? That's my competing hypothesis. So if all he's doing is pointing out, hey, it has good statistical properties when you look at the output, right? Any good solution is going to have good statistical properties. What happened to your claim that it's only an n-gram model? Justify that.
So the point is, grammar essentially is a sort of a distributional characteristic, and they capture that.
Grammar is a distributional characteristic and they capture that? Or what if grammar is not a distributional characteristic and they just actually capture the rules and the underlying structure of grammar, and then they output it, and then the output has a distribution because it's correct? Have you considered that alternative?
When I was speaking English as a second language, I knew what I wanted to say. I knew the content of what I wanted to say. It was the damn language, putting it in the right grammar, that was getting in the way, right? And so I would tend to assume that if something can actually speak the language, maybe the content is easy, because content was always natural to me. That is where people start thinking LLMs, because they can speak, write good, high, grammatically correct English, the good form language of any kind, programming languages, English, etc. Maybe they have already got the content fine too, because we actually find content easier and the style harder. Okay. And that's actually the place from which all these reasoning claims for LLMs and the factuality claims for LLMs come, and it just, they don't hold for n-gram models.
It sounds like Rao's justification so far is just begging the question. He just went on a pretty long monologue saying, people think that they understand the content and then they get it grammatically correct, and they just assume that they understand underlying content, like they understand the meaning of words, so they assume that they're reasoning, but they're not, they're n-gram models. Okay, we get your claim, but can you please justify your claim? Why are they n-gram statistical models? I'd like to know.
people out there are convinced that language models reason. I mean, for example, I had Raphael Millier on the show, and he was citing the example of Othello. And there was that paper where it's a board game, kind of similar to Go, and they said that it was learning this abstract world model, and it was generalizing. Why do people believe so deeply that these things reason?
So that's a very interesting question. The tricky part about reasoning is, if you ask me a question that requires reasoning and I gave an answer to you, on the face of it, you can never tell whether I memorized the answer and gave it to you or I actually reasoned from first principles. My favorite example is in the old days when Microsoft started having these interviews, they apparently used to ask this question as to why are manhole covers round, right? And the very first sucker who had to answer this question basically had to do it from first principles. Basically, they had to realize that pretty much any other shape, you can manipulate it such that the cover falls through, and round is the only place where actually, if you can play with the covers and they fall through, then all these holes would be, coverless. And this is a neat way of thinking, but the first few people had to do this. Right now, when anybody asks this question in an interview, the only thing you will know based on the answer of the candidate is whether or not they prepared for the interview, prepared by looking up the web and looking at what are the usual Microsoft questions. And of course, humans being humans, they will also try to say, even that people want to know whether you can reason. And so if you actually happen to know the answer, if you blurt it out, that would give it away. So you would take some time and then blurt out the answer. And so you can't tell just by the end part whether I was reasoning or retrieving.
Okay, that whole example that Rao just gave, from my perspective, is dripping with irony. So in case you missed it, he's talking about that famous interview question from like 20 years ago where Microsoft would ask, why are manhole covers round? And the answer that everybody memorized is, well, if you had a square manhole cover on a square manhole passage, maybe somebody would lift the cover and rotate it, and then the side of the square would line up with like the diagonal of the manhole, and then it would fall in, and that's incredibly dangerous. That's kind of like the cached answer that everybody's memorized. Part of the irony is that there's actually like 5 or 6 good answers. For example, if you have a round manhole cover, you can roll the manhole cover so you can transport it more easily. Also, when you have a truck driving over a manhole, if you have a circular manhole cover, it's distributing the pressure evenly, which is good because you don't want cracks to form around the corners. Like it's just a more robust shape, the circle. Also, the manufacturing process for a circular cover is simpler because you don't need to line up the corners of something like a square during manufacturing. And then when you're placing the cover on top of the manhole, it's easier to align. And also, when you're cutting the opening of the manhole, it's easier to do it with just a single cutting tool that's specialized for just cutting a certain round radius, just all the way around the hole, as opposed to needing to make like 4 separate cuts, right? So the cutting can be simpler. And then there's reasons why the manhole shaft is better off being round compared to square. Like maybe that's easier to cut, maybe that is a more robust shape that distributes pressure more evenly. So all of these different considerations that I listed, these are all dimensions of the manhole cover shape design problem, right? It's a multi-dimensional problem. It has connections to a lot of other factors. It's a kind of interesting problem. The irony is that all of these things that I listed to that make the problem kind of rich, they all came from Claude. I just typed the problem into Claude and Claude gave me all of these answers. And it seems like Rao himself didn't realize that the problem had quite so many dimensions, right? He just acted like it was a single input and a single output. And the reason Rao thinks like that is because he didn't really do much reasoning when he thought through this example, right? He just heard the problem and he heard the solution and he filed it away in his head as an example of a problem with a single solution that everybody memorized. And ironically, there was a way to reason through it, and Rao didn't opt to do any reasoning, or he didn't even opt to go and do like a broader web search to see if other people had other ideas. So there's a little bit of irony there that Rao himself, without even thinking about it, is being the non-reasoner here. But anyway, regardless of the irony, right? Because you can disagree with me. You could be like, no, it's not ironic. Rao knows about the other reasons. He's just making an example, right? My point isn't look how ironic this is. My real point is, yeah, it's a bad interview question because it's on Google, because it's in textbooks about how to interview, and because it's now at the point where you're able to answer it without reasoning if you want, right? If you care that much about memorizing interview questions, then you don't need to reason during the interview. And so if Rao himself were conducting an interview, I think he would know better than to use that question. He would use other questions that actually test the candidate's reasoning in real time. Of course, I think everybody can agree that some questions don't require reasoning. And it's our job as people designing questions to ask questions that do require reasoning. Yes, input-output, question-answer. The question-answer relationship is one that sometimes can be solved with reasoning and sometimes not. It has to do with the space of possible answers that need to be searched. If a question appears in a memorizable place, like an interview study guide, then it may have no degrees of freedom, right? You may just have to regurgitate the memorized answer. You can do that in a single computation step, right? A single memory lookup, and you don't need to reason. Now, if it had a bunch of degrees of freedom, like if the interviewer sketched out like a complicated manhole shape and said, give me the pros and cons of this complicated shape. Now, maybe the only way to answer about that exact manhole cover shape might be to, instead of memorizing one answer, you might have to memorize 10 different criteria of how you go about analyzing a manhole cover shape, right? How you go about analyzing the manufacturing difficulty, how you go about analyzing the pressure distribution once it's in place, right? So now we've taken O of 1 or a single computation step. Now maybe we've turned it into like, well, now there's 10 different checklists you go down. And so it requires more reasoning, right? There's no shortcut. The entire field of complexity theory in computer science is all about putting lower bounds on how many computation steps you need to answer a question. And it doesn't really matter if it's a human answering a certain problem, if it's, NP hard, it's a certain complexity theory designation. It doesn't matter if it's a human attempting to solve an NP hard problem or if it's a computer attempting to solve an NP hard problem. You don't have to look inside what the algorithm is doing. You're just able to say, hey, this problem, anybody who solves this problem must be doing some amount of computation. So similarly, you can just make an analogy from lower bounds on required computation, analogize that to lower bounds on required reasoning, right? And that's what I'm pushing back against Rao about. He's acting like question-answer pairs aren't sufficient to tell whether something is reasoning or not. No, you can embed a lot of evidence whether something is reasoning just by noticing that they've mapped a question to a good answer. That is something you can do. And if you take his own example of the interview question, yes, it's a bad question. Don't ask that question. Ask another question like, hey, here's a piece of code you've never seen before. Help me debug this code, right? That's a question with many degrees of freedom. There's no way to cheat on that question. So ask good questions. That's my little rant. But now I think he's going to take it the other direction. He's going to be like, look, you can't ask a question to determine if something's reasoning. Let's listen.
Many of these reasoning claims come from facts like LLMs are extremely good on the standardized tests, right? And the thing that people forget about standardized tests is standardized tests have standardized question banks.
Okay, I see where he's going with this. He's saying you get overly impressed seeing AIs pass your benchmarks because you don't realize that every question on the benchmark is similar to a Microsoft interview asking you about a manhole cover. They're just going memorized answer, memorized answer, memorized answer. So your whole set of questions is actually these O of 1 questions. Every single question is actually memorizable because you aren't varying the questions enough, or you're not giving the questions enough degrees of freedom. You're always asking the exact same question. You're always asking, why are manhole covers round? You're not giving a dynamic variable type of manhole shape when you ask the question. And that's why your tests are susceptible to memorization. I think that's his point. Let's listen further.
And I keep telling my students, you think that the hard part is answering the exam questions. Really, the hard part is coming up with interesting exam questions that haven't already been listed on the course hero, which is like this website of the kinds of the websites that exist now, where they take every possible question that has ever been asked on the exam or put on a question bank with the answer. And so students can pretty much try to prepare to the test rather than prepare to understand the material and then answer the questions on time.
Hold on, that's a different point. his point right now isn't that the round manhole cover shape question should really be a question about arbitrary manhole shapes. No. His point right now, apparently, is that writing test questions is harder than answering test questions, which is crazy, right? I mean, that's the inverse of the usual P versus NP claim that people make, right? Usually P versus NP is the observation that answering a question is exponentially harder than asking it in a lot of general cases, right? That's why we have the P doesn't equal NP conjecture, right? He's saying, no. Asking the question is so hard. If you can ask the question, then answering it is maybe not as hard. Like, it's, I don't know if I'm putting words in his mouth, but he's really emphasizing right now the difficulty of coming up with a new question to ask, which traditionally isn't thought of as a high computational complexity thing to be able to ask a question. And again, this isn't the point I expected to hear from him. So I do feel like he's shifting between multiple points. I'm not sure he's focusing on the same point for long enough for me to understand what his justification is. Let's continue to listen.
So this ultimately winds up being, in many cases where people think LLMs are reasoning, it winds up being the case that they're actually doing approximate retrieval.
So his claim is, show me a really impressive example of an LLM answering a question that looks like it's using reasoning. For instance, maybe you give it what you think is a novel medical case study. Like, here's my situation, doctor, help me about this unique combination of symptoms. And the LLM outputs, well, based on this combination of symptoms, I think this and this condition may be my two top hypotheses for what might be wrong with you. And this kind of problem was unsolved until very recently, right? It's only very recently that AIs are getting better scores or similar scores on medical exams than humans. But it sounds like Rao's claim right now is, okay, you take those examples that you're so impressed by, there's actually going to be something in their training corpus, like some sample exam or something that they actually memorized, and you actually just asked a question that was very similar to the thing they memorized, right? That's basically his claim right now.
Now, how do you show that? The usual way you get to show that is by a diagonalization argument. You almost, for example, I'll give you an example.
I'm very interested to see this example of proving by diagonalization that what looks like LLM reasoning is actually LLMs pulling up some memorized test answer. Let's see.
So I am interested in planning capabilities of large language models. Planning is a form of reasoning. It's a form of reasoning involving time and action. So one very simple kind of planning problems that people in AI planning have been looking at are things like block stacking. That is, you have a bunch of blocks in some configuration in the initial state. They could be just named blocks or colored blocks. And you want to have a different configuration in the goal state. And there's a bunch of actions such as picking up, putting down, stack, unstack, right? Given these actions, given this blocks world problem, can you come up with a sequence of actions that actually will lead to the goal state? That's the planning problem.
Block stacking is typically a straightforward reasoning problem. Like, early computers in the 1950s could follow a pretty simple set of rules to derive what series of actions could stack blocks a certain way, right? Typically, the hard part of getting a robot to stack blocks turns out to be like looking at the blocks and identifying where to place its hand to pick up the block, right? It's kind of like the fuzzy parts of the blocks, not like the rigid logic of which block to place where. But okay, let's run with this example.
Interestingly enough, original LLMs like GPT-3, etc., were very bad at this. GPT 3.5, in fact, and GPT-3, in fact, I think in 2022, we wrote this thing when everybody is making claims about planning capabilities that no, they can't. In fact, they get close to 0.6% accuracy. They're just guessing, and then the action sequence won't lead them to goal.
Yeah, so there's always been kind of an impedance mismatch between LLMs and these kind of pure logic problems or pure math problems, like factoring a number. If you give GPT-2 or GPT-3, one of these earlier word completion AIs, and you said, hey, how do I stack these blocks, or how do I multiply these numbers, or how do I factor this number? It would kind of be coasting, right? The same as like a human who doesn't really understand math or logic. And you're just like, hey, what's 52 times 43? And they're just like, you carry the 5 and then you get 319. Like, they're kind of like BSing it, right? They're kind of just like trying to trick you by spitting something out that sounds convincing, right? That's normally the MO of LLMs. But with these smarter LLMs, they have like a big enough corpus where they start to get trained to predict the answer better, like an answer that makes more sense. So they can't just like BS some random digits at you because they've seen enough examples in their training corpus where somebody's factoring a number and the answer has more justification. Like, no, the factors are this because there's this internal structure, like they do a little bit of actual multiplication or actual addition or actual representation of block stacking, right? So things come online that are more than like shallow word statistics, because that's the whole scaling hypothesis, right? You scale these AIs to be larger and they stop being so surface level. Like they make the prediction more accurate because they actually have a deeper understanding, and thereby they get a better score, right? Their loss function gets a lower value, right? Because they're doing better by actually understanding stuff. So I'm not surprised that he's using block stacking as an example of how the earlier GPTs didn't do well. But as we approach the limit of smarter GPTs, they seem to be using true reasoning to solve it. Or aren't they? Let's see his claim that they still aren't.
Interestingly, when GPT-4 came, and you might remember that Sebastian Bubeck and co wrote this, the notorious Sparks paper. And so we were interested in seeing maybe are there the Sparks going to help the planning capability? So we checked GPT-4. Interestingly, it increased in accuracy. It's still nowhere near 100%, but it went from something like 0.6% to close to 30%. So you can argue that, wow, if GPT-4 is 30%, GPT-5 would be maybe 70%.
Yes, I think we should all make that argument as something that has a very significant probability. I think we should all wonder if the next scaled up LLM will have higher than 30% accuracy on this particular type of test problem. And I don't think anybody can confidently say that it won't.
And by GPT-10, you can get 150% accuracy of some sort, right?
I get that that's supposed to be funny to talk about 150% accuracy, but he's also being very dismissive of a perfectly reasonable hypothesis.
The question that we asked ourselves is, can you explain this potentially in terms of just the retrieval as against actually reasoning? If you are doing reasoning, then if I take the blocks world and change the names, things like instead of stack, I will say feast. Instead of unstack, I will say slap, something like that. So if you have any background in logic, you realize that the predicate names don't change the dynamics of the system. And so any planner which can solve the original domain can solve this with exactly the same efficiency and accuracy. You give this to GPT-4, it dies. And in fact, we wrote this paper called PlanBench paper for NeurIPS 2023, which essentially shows both the blocks world logistics kinds of planning problems as well as these obfuscated versions of them. And it's almost like a fun sideline for us that Karthik Valmikam, who is the lead author on that paper, he keeps running every new sort of LLM, GPT-4o, and Claude, and Gemini, and they all basically are stuck close to zero because they are essentially guessing the plans for blocks world because they have the word, they have the usual words associated with blocks world, which are stacking, unstacking, etc. And there's enough of the data for that in the web scale corpora. But you change the words, they're completely lost. So that is a great way of showing essentially that they are not doing reasoning. Because if you were doing reasoning, you should be able to solve this just as easily as the original one. So in general, I can understand why people easily fall for this, because typically, as I said, when people answer a question that requires reasoning, you can't tell just on the face of it whether they just happen to have heard the question and the answer before they came into the room and they just blurted it out, or did they actually start from that question and answer it by reasoning.
Okay, there is actually some empirical substance to the argument he's making right now. I haven't looked into his blocks world paper that he's talking about, but I have played around with some other examples that he's given in the past, like a year ago. I have seen some examples where if you go ask the AI a question, sometimes you can change the words a little bit and it will screw it up when it's kind of surprising that it's screwing it up. It's like, wait a minute, if it got the original question, shouldn't it still get this small variation? So he is onto an empirical phenomenon here, right? Like sometimes that is a real thing. But it's not always that easy to screw up the AI. Like, we do have many examples where you ask it a question, it's a pretty hard question, the AI nails it. You ask it a variation of the question that it's never seen before, it nails it. The variation is still hard, but it nails it. You ask it another variation, it nails it. You ask another variation, oh, it messed up that variation, it didn't get perfect. You ask another variation, it nails it, right? So that's the behavior we see is like, yes, sometimes you screw it up and it's like, wow, why did that screw it up? And when it screws up, it kind of makes you suspect like the whole illusion got shattered and you're like, oh man, you betrayed me right now. You betrayed me. I trusted you like you were truly reasoning, but then I modified the problem and suddenly you had no idea what I was talking about. And that proves to me that you were faking it when I thought you were reasoning. I feel like that is Rao's argument right now, right? Like the fact that it doesn't robustly move with you to every variation that seems like a small variation shatters the whole illusion in Rao's mind, right? That's kind of my attempt to paraphrase his point. But here's the thing. It's not a requirement to nail every variation. It's already impressive to have even a decent rate, like a 30% rate of getting a bunch of different hard questions right. You can't dismiss that. Getting those hard questions right is ridiculously hard. That doesn't prove that it memorized. It doesn't shatter the illusion. Like the fact that you changed it and then it got it wrong, you can't then go revisit the instance that it got right and dismiss it. No. Those instances that it's getting right, like, in the case of like the medical exam question, let's say it got one medical case study correct, and then I slightly changed the words, I obfuscated a little bit, and then it gets it wrong. That doesn't let me dismiss the medical case study that it got right, because the one that it got right, it wasn't like a multiple choice question where you guess A, B, or C. No, to come up with the correct hypothesis, there's like a million different answers, right? So it was doing a 1 in a million guess, and it hadn't seen it before. It wasn't literally copied it out of a book. It was a big variation, right? There were a lot of degrees of freedom changes from anything it had ever seen in an example set of test questions before. So that's really where I diverge from Rao. I remain impressed at the instances of difficult problems that it's getting right, even if I see trivial modifications then leading to it getting it wrong. That does not shatter the illusion that it's actually reasoning for the ones that it gets right. And then you can ask, well, what if it mostly gets it wrong and it's rare for it to get it right? And I think that is the heart of the matter, is how often can it get things right? And the ones that it gets right, how impressive is it that it got to the right answer? There's obviously questions that are very hard that if you'd asked me 5 or 7 or 10 years ago, I'd be like, no, that's way harder than anything AI can do. Like, we don't have a way to shortcut getting this answer right. We don't have a way to memorize these test questions and get them right. Even with hundreds of billions parameters, that's not going to get you the right answer, right? So they're clearly doing impressive things, and it does not negate that just because some variations of it they're not getting right. I will give them this. I do think that it does represent a limitation, an imperfection, right? The fact that you can change some keywords and then have it some of the time screw up the AI's answer, I do think that indicates that they're not perfect yet, right? I don't think we have superintelligence yet. I don't think we have AI that can beat even a moderate human at like life skills, right? I don't think we're in the singularity yet. So he's raising a good point there, but to treat it as, in his words, a diagonalization argument or some kind of proof that they're not reasoning is going way too far.
It might be interesting to have a small digression on what reasoning is. Now, I'll give you my definition. So I think it is performing an effective computation to derive knowledge or achieve a goal using a world model and all existing semantics. So, you can think of it very loosely as, deriving kind of truths that we don't currently know, if that makes sense.
I feel like Tim is kind of throwing the kitchen sink into this definition. So first of all, he says, performing an effective computation to derive knowledge or achieve a goal. Those things are kind of different. Are they both sufficient conditions? So if I just derive some knowledge and I don't achieve a goal, I'm reasoning. If I achieve a goal but I don't derive any knowledge, I'm reasoning. Can the goal be really simple? What if the goal is to just say anything, right? And then I've successfully said anything, so that I just do reasoning? Did I do a trivial form of reasoning? Is there a scale of reasoning? If there's a scale of reasoning, shouldn't we just define the metric instead of try to use like a black and white definition? So I'm not really vibing here with Tim's definition of reasoning. It does kind of seem like buzzword bingo from my perspective. I haven't even finished reading his definition. He says, derive knowledge or achieve a goal using a world model and all existing semantics. Okay, but again, it could be like a trivial goal. Like, I'm not clear on where his definition really starts and ends. And the last thing Tim said is, you can think of it as very loosely deriving truths that we don't currently know. So you really have to derive truths that we don't currently know just to do reasoning. Like, it doesn't count as reasoning when I said, hey, I better check my email so I can find the coupon code for my Instacart grocery order. Like, I wasn't reasoning. I was just completing a meaningless pattern. I don't know. It felt like reasoning. It felt like I was chaining together some inferential steps in order to do something useful in my life, right? The kind of thing that an AI wouldn't even be super robust at doing today because it's kind of hard. Like, that doesn't count as reasoning. Or maybe it's like an easy form of reasoning. I don't know. I'm not getting a lot of productive value out of Tim's definition. And of course, if you watch the channel, you know my preferred definition, where it's really just whatever you do in the middle to answer sufficiently hard questions. So what I do is I punt all the meaty goodness of reasoning. I punt it all to the mapping between the question and answer. I think that if you have a trivial question, it's not interesting to ask how much reasoning it takes to answer it. So if you have an interview question like the manhole cover, and you know that the correct answer from the Microsoft interviewer's perspective is that you don't want the manhole cover to accidentally fall into the manhole, and that's why it has to be round, then that's a single computational step, right? That's a single lookup. And so asking that question in a context where the exact answer is in the data, it doesn't require reasoning because there's this trivial shortcut. So you have to ask a question that doesn't have any shortcut if you want to claim that reasoning isn't required to solve the question. I'm pretty adamant about this. Like, I will kind of die on this hill that reasoning is only an interesting concept when you have a non-trivial input-output map. Okay, and now once you do have a non-trivial input-output map and there's no cheating in the environment, like the environment doesn't have like some ready-made solution that you can just grab so that the input-output map actually does become trivial, right? So for example, if I ask you like, what is the prime factorization of, and then I give you like this 1,000-digit number. Well, normally I'd be very impressed if you could figure it out because factoring is thought to be a very hard problem. But if it turns out that I ask you the question because I multiplied two large primes and then you found my Post-it note where I wrote down the two numbers I multiplied and you just repeat back to me what you saw on the Post-it note, like you're basically cheating. If you do that, then I'll be like, okay, well, the question I asked you just happened to be a lot easier because this extra context made it easier. So again, I'm only impressed by the amount of reasoning that it takes to answer a question if something is fundamentally hard about the question, like if it has a high computational complexity, right? Like if it has like a known lower bound or a conjectured lower bound in the case of factoring. It's kind of funny to me how like the Tim Scarfs of the world or Keith Duggar, if you go and watch my debate with Keith, a lot of these guys will just not adopt my definition where it matters so much about the input and output of what you're doing. They really insist on trying to open the black box and being like, okay, if you did the right actions while you were solving the problem, then I'm going to give you credit for reasoning even without referring to what the problem was. Like that's more of their approach, right? They're more focused on the process, whereas I'm more focused on the relationship between the starting point and the destination. Right? Like people who say like, oh, it's not about the destination, it's about the journey. I'm really much more about the difficulty of the destination, regardless of the details of the journey. It seems like Rao is on the Tim Scarf and Keith Duggar side of things, where Rao, I think, really wants to open the black box and look into the process before he's going to be willing to count something as true reasoning. But let's hear what he has to say.
Yeah, so I would go back to, first of all, reasoning is pretty well defined from a logical perspective. That's one particular kind of reasoning that we have understood from the Greeks on, right? And, that I always find that it's useful to just go back to that, even though, there's all sorts of reasoning. Logical reasoning is certainly one very important kind of reasoning. And as you said, in the case of logic, given a set of base facts, you're trying to see whether some new facts will follow, in the sense is the deductive closure of the knowledge that you have, are these other things present.
Okay, but if you're just talking about deductive reasoning, we've had computers that can perfectly deductively reason since the 1950s, right? So what is the missing piece here? Like, you want to say that today's LLMs can't reason? They can certainly just call functions that can deductively reason perfectly, right? They can punt over to algebra solvers or all kinds of deductive reasoners. So why are we talking about this as the definition of the secret sauce that AIs don't have, when, again, if you just focus on the difficulty of the problem, you're just talking about problems that were solved in the 1950s, right? Like logically deducing things is something that we all know computers are much better than humans at, right? Computers tend to be better than humans at logic. They tend to be better than humans at stacking blocks, right? Better than humans at finding the shortest route, better than humans at playing a heavily logical game like chess. So where are you going with this, Rao?
This is actually a very important distinction. So everybody in AI used to know logical background, but nowadays, most of the grad students actually start with just deep learning courses and machine learning courses. This is very important technology. I'm not questioning that at all, but you need to understand that the in versus out of distribution, the usual terminology that people use in machine learning, that's for databases. For reasoning, you need to think in terms of deductive databases at the minimum, which is you're not just looking to see whether the stuff in the database, basically whether the query that you're asking is in the same distribution as the kind of queries that you already presented previously.
I don't accept that premise that what LLMs are doing is checking whether their inputs are in distribution of stuff that they've seen before. I think they're getting novel inputs all the time. It's Rao's premise that they're not. It's Rao's premise that there's some sort of statistical relationship between novel queries that you and I are asking to our AIs. Rao claims that they somehow fall inside of a statistical distribution of inputs that these LLMs are seeing. I don't find that to be a meaningful claim. I haven't heard Rao justifying it, but he's kind of moving on, taking it as an assumption that there's some sort of statistical thing happening here, and then he's going to contrast that with, it sounds like he's talking about Prolog or Datalog, right? These kind of deductive databases, and he's drawing a contrast, but I'm just not following his original premise about LLMs being statistical, but let's continue.
Instead, you're looking to see whether the system is able to compute things in the deductive closure. Okay, that's what winds up requiring logical reasoning, and there's no reason to believe that LLMs can do that. And one of the very interesting, first of all, there's actually increasingly more and more evidence showing that this definitely can't do it. We've been saying that as a corollary of the fact that they can't do planning, they clearly must be failing in doing, deductive closure. But people have even shown, recently there was a paper which talks about some sort of a transitive closure. Transitive closure is a poor cousin of deductive closure, which is if you, let's say, A, P1, B, P2, C, okay, you should be able to say A, P1, P2, C. Yeah. If you can't do that, you certainly can't do deductive closure, because transitive closure is a really small part of deductive closure. And so that's one way of realizing that LLMs cannot do reasoning.
Okay, here's another example where there is some empirical weight to this. Like, I've seen examples of trying to tell LLMs to follow computer program instructions step by step. And what I see is that the LLM kind of starts doing it, kind of gets it, but then pretty quickly messes up. And then once it messes up, it tends to kind of spiral into messing up more and more, and it doesn't really fix itself. So what he's saying about, hey, they can't even do transitive closure, they can't do deductive closure, it sounds very similar to what I've witnessed, where it's like, hey, it pretty quickly screws up a problem that seems like it should be able to solve because of how smartly it's talking, but it was all just an illusion because it can't even know that like the law of transitivity applies to a few variables, right? Like, it messes up something that seems kind of simple, and then it's like game over, and then that proves that it like never knew anything because it can't even do this simple building block. And yet, once in a while, you give it like a harder problem and it somehow tells you the answer to the harder problem, right? Even though you kind of proved that it doesn't even understand the basics. Well, somehow it got the answer right to a harder problem, okay? Somehow it happened. I always talk about how I don't see a fundamental separation in the kind of reasoning that LLMs can do versus can't do. I don't see a fundamental barrier, but I do see them not being robust. And in my mind, what would advance the next generation of LLMs is to just like mess up less often, which is what I would describe as the step from GPT 3.5 to GPT 4. I would describe that step as like, yeah, it's doing a lot of the same stuff and it's messing up less often, right? I do see that progression. So from my perspective, when Rao is pointing out, like, look at this test we did where it messed up so many of these problems. Yeah, I agree. It sometimes messes up. But again, it's also impressive that sometimes you do give it instances of the same problem and it does get it right. So it's not like you have a simple problem that it never gets right. Right? I'm certain, I haven't seen the paper, but I'm quite certain that you're just talking about a fraction of the times it's getting it wrong, right? It's not always getting it right, but it's not always getting it wrong either. So when Rao gives examples of things LLMs can do, it's the point I said before. That doesn't disprove, that doesn't say, so they were never reasoning all along. I feel like that is the crux of our disagreement. Because when I see certain inputs, novel inputs, complex inputs, somehow getting mapped to correct outputs, I'm pretty much ready to say, okay, it was reasoning. Like that's pretty much all reasoning is in my book because you can't fake that. You can't fake your way to an answer to a novel medical case study. Try it yourself, right? Go try to take the medical exam and have like the biggest lookup table in the world and try to pass a medical exam. Like it's not easy because again, if it was easy, we would just have used a giant lookup table in the year 2010, right? It wouldn't have taken us until the 2020s to do this lookup table hack. So again, the crux of disagreement between me and Rao, it seems like Rao throws the idea of reasoning out the window when he sees examples that look easy to him that aren't being solved, whereas I focus more on the miracle that some hard novel problems are able to get solved. And I say the strong points tell you that reasoning must have happened, even if they go together with weak points. A passing score on the bar exam or a medical licensing exam, those kind of passing scores, you never get those by chance. You can take the bar exam multiple choice every day of your life and you're never going to pass the bar exam, right? So the fact that the AIs are passing on these kind of hard exams, that to me is so much Bayesian evidence, right? It's so much impossible to fake legitimate evidence that they're doing complex reasoning that if they then go on to choke on a bunch of really easy problems, that's still okay. I'm still convinced that they're reasoning. I don't throw out the evidence that they're reasoning the way Rao seems to be doing.
Now, people say, but no, there are things that LLMs are doing that are not considered base facts.
Right. Like I claim passing a medical licensing exam full of case studies is more than regurgitating base facts, right? That's why we couldn't do it until recently.
But that actually is because we don't really understand the training data. The training data is not something that we put together. It is the entire web. And everybody thinks that they know what's on the web. Nobody really understands how many things are on the web.
The answer key to every year's medical licensing exams are all on the web in the training data. When there's a new medical licensing exam, the questions on that exam are all just copied from exact questions on the web.
So I keep remembering this thing that when Palm, the old Google LLM came about, one of its great claims to fame is it could explain jokes. Why is that like an AI task is beyond me.
Because it requires semantic understanding of concepts that are being referenced by words in the joke, usually with a ton of ambiguity, where the only way to dereference the pointer of what the joke is talking about is to actually have a web of interconnected knowledge about a bunch of different concepts, what many of us call solving the symbol grounding problem. So again, this is incredibly impressive that AIs in the year 2024 can explain arbitrary jokes, right? Like you can make up a new joke. You can have the AI explain it. I've seen it explain some pretty crazy jokes that even humans might have trouble explaining. And it gets it. Like we have AIs that get things. So maybe that answers Rao's question as to why we test AIs on their ability to explain jokes. Seems pretty clear to me why we do that.
But it is surprising that it could kind of explain jokes. And so you'll be very surprised, wow, it is actually able to do some sort of thing that's beyond the data. But really, I don't know whether you know this, but there are humor challenged people in the world, and there are websites that explain jokes. And these websites are part of the entire web crawl that the system has been trained on. And because of which, it's not that surprising. So reality is, in normal logical terms, you would think that I gave base facts and the system says something that's not typically a base fact, then it must have done some kind of a reasoning. But oftentimes the web corpora contain both what we would consider base facts and what we would consider parts of the deductive closure in an interesting, mishmash way. And so when once in a while it actually winds up retrieving the stuff from the deductive closure, you would think it's actually reasoning because you think it couldn't have probably been in the web. That's because you don't know actually what's on the web. It's very hard to show that what is and what is not on the web.
Rao is making a very bold claim here. He's saying AIs explain jokes because they've been crawling various joke explainer websites, and they're really just regurgitating explanations of jokes that some human has written. Okay, Rao, just to prove you wrong, I took a joke that I thought up myself. It's actually a joke that I tweeted a couple months ago, and it actually went viral. So it's a pretty good joke. It's very dark humor. I joked about the October 7th Nova Music Festival massacre. So it's kind of gallows humor. The joke is, October 7th changed everything. Billy McFarland just changes LinkedIn to say he's the founder of the second worst music festival. Okay, it worked better as a tweet. Like I said, it actually went viral, so I didn't delete it because a bunch of Jews were liking it. I'm Jewish myself, so it's okay to joke about it. But it's obviously a huge tragedy, right? So I don't know, maybe it is too soon. But anyway, listen, the point of this is that it's a novel joke, okay? It's proven to be entertaining to humans based on the Twitter virality. It also has no results on Google explaining it, which isn't surprising because I personally thought of it. So I type it into Claude. I say, Claude, explain this joke. October 7th changed everything. Billy McFarland just changes LinkedIn to say he's the founder of the second worst music festival. What do you say, Claude? And Claude says, this joke references two separate events. One, October 7th, 2023 marked the Hamas attack on Israel, a tragic event that had major geopolitical ramifications. Two, Billy McFarland was the organizer of the infamous Fyre Festival in 2017, which became known as one of the biggest festival failures in history. The event promised a luxury music festival experience in the Bahamas, but descended into chaos with inadequate accommodations, food, and infrastructure. It resulted in multiple lawsuits and McFarland's imprisonment for fraud. The joke implies that McFarland is making a dark, self-deprecating reference on LinkedIn by suggesting that his disastrous festival is no longer the worst music festival, in light of the October 7 attack, which occurred during the Supernova Music Festival in Israel, right? So that's what I was comparing it to. The humor comes from the inappropriate and tasteless nature of McFarland attempting to make light of his own scandal in relation to a tragic event. The joke points out the stark contrast between what was merely a fraudulent business failure, Fyre, and a devastating humanitarian tragedy. Right, exactly. Claude completely understood my joke, and it's never seen that example before in the training data. What do you say to that, Rao? I mean, to me, this answer is wildly impressive. And to be honest, I typed it into GPT-4 too, and GPT-4 didn't quite get it. It was just saying, well, you're juxtaposing the Fyre Festival with some kind of event that happened on October 7th. And I'm like, do you know what happened on October 7th? And it was a little bit confused. It didn't make the connection to the Supernova Music Festival. But again, it doesn't matter what the AI sometimes can't do. It matters that once in a while, they have this kind of stroke of genius. I mean, Claude got it on the first try, and this is brilliant, right? This is a brilliant inference. This is the kind of thing that the people on Twitter read it, and they got the inference that I was making, and they thought it was worth retweeting, right? And laughing at. I mean, this is like the essence of humor, right? This is like part of what makes us human. And here's Claude just nailing it on the first try, right? Within like seconds of spitting out this output, right? Claude 3.5 Sonnet. So I just don't see what Rao is getting at. He's kind of taking the pinnacle, the highlight, the crowning achievement of what today's LLMs are capable of doing. And then he's going to downplay it by claiming that it's coming from some existing knowledge base that a human wrote. And by the way, when I posted that joke on Twitter, I didn't just write it out. I made like a fake screenshot where you're looking at Billy McFarland's LinkedIn and you're saying that he's like changed his bio to talk about the second worst music festival. Anyway, too soon, right? I mean, Israeli hostages are still being held. Like, you know, I feel bad even bringing this up now, but it is a really good example of novel joke. So I'm going to keep it in. Let's continue.
I actually have an experiment that this Tom Griffith's group did that I really repeat to a lot of people. That again makes the same kind of a point, which is one of the sparks that the original GPT-4 paper talks about is that GPT-4 can do cipher text decoding, right? And Caesar cipher decoding. And so what these guys basically did is check, because Caesar cipher decoding is just basically based on like an offset, right? And so you take A plus 4, then you take the 4 letters off from A and then replace A by that. That's the usual thing. So for each offset, there's a code. And so they try to see how well does the system, GPT-4, decode for different offsets, 1, 2, 3, 4, all the way to 25. And surprisingly, they find there's a huge peak at 13, and it's basically close to 0 anywhere else. And why is that interesting? If you remember, or if you're old enough, you'll remember that in Unix, there is still a command called rot13, rotate by 13, which is, while Caesar cipher is a general idea, 13 is the special case, that is rotating letters by 13 is the special case that Caesar cipher is more famous for. And there's tons and tons of data of normal text and rotated by 13 text on the web. So that's the part that LLM does well, and it doesn't do well for 2, 3, 4, all the way, and any other number.
Okay, so the empirical observation is that GPT-4 is going to be better at spitting out Caesar cipher decodings when it's rot13, when it's shifted by exactly 13 letters as opposed to like 4 or 5. Yeah, this is totally plausible. It maps to what's called System 1 in humans, right? So in humans, there are certain things that we just kind of process natively with more ease and fluency. There's things where there's more shallow patterns that we're just used to seeing over and over again, and so they become intuitive for us. Like if you're a human, if you're used to reading a lot of English, have you ever done one of those tests where you see a bunch of words and the letters in the words are scrambled around, but you just kind of recognize that bag of words, and so you can kind of read like it's no problem? Well, imagine you're learning Spanish, right? And you're not as familiar with the words. You'd probably do a lot worse at the bag of words test. But if you had more time to unscramble the words, you'd probably still do okay, right? You'd just take like 10 times more time. It's very much the same thing with an LLM and rot13. So it just has kind of an intuition, a shallow pattern matching for a bunch of words that it's already seen rot13 before. So they kind of flash into its next character, right? It can kind of get it as part of its like smooth stream of consciousness. It can kind of coast the way you as a human might coast if you're just reading these jumbled up letters in a language that you're familiar with. Like, it's no problem. The answer just comes to you, right? I don't think that there's a profound insight of like, wow, GPT-4 doesn't truly understand the Caesar cipher. It only pattern matches rot13, and it's totally confused about a Caesar cipher with a step size of 5. I really don't think that's the case, because you can dialogue with GPT-4 or with Claude. You can dialogue about what is the Caesar cipher, how do I apply the Caesar cipher, what is the step-by-step, let's think step-by-step, and let's get the Caesar cipher for this word. So if it brings System 2 online, right, this kind of explicit understanding of what the Caesar cipher is, it's going to nail it. And it's also going to be able to write Python code to do the Caesar cipher, the same way that a human might essentially write code for themselves, right? Give themselves instructions like, okay, 1, 2, 3, 4, 5, I'm moving the letter by 5, I know how to do this, right? So to me, this isn't damning evidence of like, oh my God, AIs can't truly reason because they have like a better pattern match for rot13 than rot4 or 5. Like, this actually, it's almost like a human thing that they're doing, right? Like, I identify as having a human brain that can sometimes coast, that can sometimes do things comfortably, right? Like if I see piano sheet music, I play the piano. So if I see like a chord that I'm familiar with, my fingers will just kind of snap to where they need to be. And if you show me piano music that's in like a really weird style that I've never played before, suddenly I'm like really slow and I have a harder time with it. Am I just pattern matching? No, I'm reasoning about the music, right? I'm a fully general musical note player. It's just that some configurations just load right into my fingers, right? Because the whole end-to-end, all the levels of the hierarchy are just like tuned to process this particularly efficiently. But now Rao is going to take this evidence about the Caesar cipher and rot13, and he's going to try to generalize a point which gets back to the crux of our disagreement. I think he is drawing the wrong lesson from this kind of thing. Let's listen.
And I think if I might be so bold as to say what's somewhat wrong about the kind of empirical studies on LLMs is that people tend to stop at the first sign where they get interesting results. And I think you have to be very skeptical. You have to assume by thinking that the system does not have, certain capabilities, and then actually try to, poke holes rather than write a paper right away.
No, sorry, I disagree. There's certain individual tests that if you see an LLM passing it, that's a eureka moment. When I wrote a viral tweet making light of the October 7 massacre and humanitarian crisis that's still ongoing, when I joked around about that and then Claude 3.5 Sonnet instantly unpacked why it was funny, that is a eureka moment. You can write a research paper about just that. If I then go and tweak the joke and Claude 3.5 Sonnet suddenly doesn't understand it anymore, it fails to get the reference, it doesn't matter. It doesn't matter. That single example is incredible. There's nothing that can dampen the sheer excitement of getting that one particular example right. It's like if I hide a bar of gold in the Sahara Desert and I have a friend, I don't tell the friend where it is. The friend flies into the Sahara Desert at some random location, somehow goes to the right location where the gold is and grabs it. That is a very interesting thing that you can write a research paper about. Like, how the hell did that happen? That begs for an explanation. That is not a phenomenon that you can expect just by having that friend, they studied a bunch of maps before. Like, what? No, something begs for an explanation. So just to reiterate, the crux between me and Professor Rao is that Rao thinks that you can undo this kind of achievement. He thinks that as long as you can find variations that it doesn't get, then it shatters the illusion of the original achievement. But I'm telling you, nothing can shatter how impressed I am with the fact that it just unpacked my novel joke. Nothing can shatter that. That is a real reasoning achievement, Rao.
And currently we are going through a hype cycle where essentially both in research and in commercial terms, where people are just happy to write LLMs are zero-shot XXX, where XXX is reasoning, planning, something else, and mental modeling, etc., etc. And it turns out for most of these, you can find that really you can explain the results from an approximate retrieval point of view, because by diagonalizing, in fact, as I mentioned, the planning where you change the names, that's a diagonalization argument. What these guys did in checking whether it can do ciphertext decoding for something other than 13 is another diagonalization argument. Because if you know the general principle, you should be able to do it. If on the other hand, you're memorizing, you won't be able to do it. And so that's a classical way of finding, but showing that it's not doing reasoning. But I agree that typically, in general, it's easier to be impressed because coming up with these diagonalization arguments is hard. But from a scientific perspective, we need to see, whether or not they actually have these capabilities.
So yeah, what Rao just said is exactly what I'm saying is the crux of disagreement between me and him. So I think we've nailed it. I'm just going to beat a dead horse right now. I'm just going to reread you the last thing Claude 3.5 Sonnet said when I gave it my joke. And just keep in mind, Rao is telling you that this is not real reasoning, that this is just memorization. Here's that last sentence from Claude. The joke points out the stark contrast between what was merely a fraudulent business failure, the Fire Festival, and a devastating humanitarian tragedy, the Supernova Music Festival. Claude figured out the deep meaning of the joke, Rao. When Rao talks about a diagonalization argument, if I understand correctly, he's saying, yes, you can take an example like this, but then you can build on it in a way that Claude will no longer work. But how does that undermine the achievement that it just did, coming up with such a good, perfectly on-point analysis? There's literally nothing that I would add to this analysis. It completely understood every little nuance of this joke. The fact that Billy McFarland posting it on LinkedIn probably represents a lighthearted self-awareness by McFarland himself, and that's inappropriate. Like, all of those layers are as correct as they could possibly be. And you're telling me that this is just some lookup on the internet? Let me go use his term. What did he call it? He calls it approximate retrieval. Like, oh yeah, everything that Claude just explained about that joke, that was just approximate retrieval. I've diagonalized away the idea that it was doing reasoning, guys. Don't worry, nothing's going on here, just approximate retrieval, just statistics. Are you kidding me? The statistics of comparing the Nova Music Festival in Israel to Billy McFarland's Fire Festival, that's in your statistical distribution. That's just using n-grams to figure out what the correct analysis of that joke is. Come on, man. Look at the actual example. There's many like this, right? That when it passes benchmarks, it's doing this kind of stuff. This is deep stuff. This is all there is. When it comes to being intelligent, it seems like this kind of stuff is pretty much all there is. Like, it's not clear what else there is besides just like doing it more robustly. That's it. I don't know what else there is.
Yeah, I mean, a few thoughts on that. I mean, it's interesting that people are not more skeptical. I mean, my religion is skepticism.
Yeah, I think so. Science is supposed to be skeptical in general.
This part's annoying because they just keep going under the assumption that Rao is correct at downplaying the reasoning achievement of GPT-4 and Claude. And then under the assumption that Rao is right and we're wrong, now you have to psychoanalyze Liron. Like, why can't Liron see how much of a stochastic parrot GPT-4 is. Let's psychoanalyze Liron.
In general, humans are not good at giving credit to anything. In general, they would like to say it is their idea, except strangely enough, with LLMs, they're willing to give credit to LLM than to themselves, because I think my cynical way of looking at it is, if you say LLM did it, you get a New Rips paper. If you say you did it, who cares? It's not supposed to be impressive.
Yeah, so I'm just some guy who likes giving credit to LLMs, whether their output is a slightly modified version of some joke explanation that they saw on the web, or a totally novel, right on the nose, zero shot unpacking of the exact joke that I personally came up with. Yeah, whatever. I just like giving the LLMs credit. That's just my psychology. That's just my desire to write a New Rips paper. You got me, Rao.
To some extent, people are suspending their disbelief too easily. And that is not a good thing for science. I mean, if you're doing it, if I'm a startup, clearly, yeah, the whole point is, let's hope that the world suspends their disbelief while I make my millions, right? But science, it's a different thing. And so one of the interesting questions is, what's going to be the half-life period of many of these LLMs or zero-shot XXX kind of papers? I have this full-on tongue-in-cheek. I have said on Twitter that when some of these papers are shown to be kind of wrong, they should lose their citations. Right now, what happens is the bad papers, which actually made claims that actually were proven to be wrong, they still keep gaining citations because people will say, they said this and it was wrong. I think one way of designing the mechanism is that if I prove your idea to be wrong, I should get all your citations for the bad. That's to the extent for us, the citations is the currency. I mean, obviously I'm being facetious, but in general, that reduces the incentive for people to rush to print and hope that maybe, basically they may be right. And even if it's not right, they will get some amount of attention.
You want to talk about accountability for people's research papers? Look at your papers, Rao. I've actually tweeted to Rao a couple times about this, which is, I don't see Rao making a falsifiable prediction in any of these papers. Like when he says, hey, these can't really reason. When they explain jokes, they're just using memorized answers. I'm not seeing him put a stake in the ground being like, hey, here is my own benchmark. Here are some questions that have degrees of freedom that aren't on the internet. And I will privately test the next AI. And if it passes these questions, then that'll actually falsify my research because I predict that it won't answer these questions. And of course, show those kind of questions to an independent auditor, right? So he can't cheat, or, maybe publish them online, but ask the AI companies not to use them. Like whatever it is, I don't see him making a falsifiable prediction. I may be wrong, but from my perspective, I see Rao's MO as being to always look backwards, to always retroactively turn around and be like, hey, look, I found situations where current AIs aren't answering something, right? And all the way until superintelligence, you're always going to be able to turn around and be like, aha, there's still a gap between the current AI and superintelligence. It's more inconsistent at zero-shotting these particular versions of Caesar Cipher, right? Like you can always find something. But Rao, let's put a stake in the ground. I would love to see you predict something falsifiable. I had the same problem on Twitter with Martin Casado. He also is somebody who thinks he knows a lot of limitations about AI, but it's very hard to get him to predict something confidently that AI won't be able to do in the next couple of years. In the case of Martin Casado, he engaged with me enough to give me an excuse why he can't do it. He said, I can't tell you what AI is going to do in 2 years because I don't know what data it's going to be basing its answers off. So I have no answers for you. And I tried to keep the conversation going. I tried to say, well, can you make a statement where conditioned on the AI being able to do something, we should expect to find a particular type of data? Or can you say, hey, assuming that it doesn't have this type of data that I can give you some description of, assuming that that doesn't exist, like this novel source of data, then I bet that it still won't be able to solve this. Like I bet it won't be able to win gold in Math Olympiad unless this other new type of data set gets created. Can you at least say that? But he stopped responding at that point. So I see both of these individuals as very much not participating in the kind of productive constraints on how humans need to do science, right? Because humans, we're all biased. We all want to be right. We all want to have the ego trip of being like, look, I knew this was going to happen. I called it, right? I don't fault you for having that ego. I mean, I feel the same way. Where like, I like to be right. I like to be credited for predicting things in advance. I hear you, but like Rao, the spotlight really should be on you right now to tell us what will the next generation of AI not be able to do. The reason I think this is so important is because I think that if Rao had only seen GPT 3.5, which couldn't quite unpack the joke that I told, I think, or maybe GPT 3 couldn't quite do it. I don't actually know exactly where the threshold is for GPTs being able to unpack the joke I told. All I know is that Claude can do it really easily right now. If you'd only shown Rao GPT 3, I strongly suspect Rao would be like, yes, understanding this kind of novel joke is infinitely beyond the capabilities of LLMs because it's not in their training corpus. To me, that sounds very much in character for Rao to say that. I don't want to tell you for sure that I know that he wouldn't say that. Even he doesn't know if he would have said that or not because it's too late, right? Like we all already know that Claude can do it. But like, I think Rao is very much just using confirmation bias and just retroactively acting like he knows something about what AIs can't do, but he's heeding and looking at the results of what they can and can't do. I don't think he ever makes predictions about what they can and can't do. And so people like him, unfortunately, are always going to be around from the present all the way up until the time of superintelligence, recursively self-improving superintelligence. You're always going to have people like Rao at every stage being like, aha, I knew that it can't do this after peeking at what it can and can't do.
I want to bring in creativity. So first of all, when we do deduction, we are applying these rules that could work in any situation. But if you think about it, we can compose these deductive rules into this big kind of tree, into a big graph. Mm-hmm. It's similar to in the physics world. We talk of the physics world being causally closed, but we're talking about like a deductive closure. And what is the role of creativity when we traverse this graph?
That's it. First of all, that's an excellent question. In general, this actually, despite what the tenor of our conversation until now, I actually think LLMs are brilliant. It's just they're brilliant for what they can do. And I don't complain that they can't do reason, use them for what they are good at, which is unconstrained idea generation.
Okay, I reject that characterization of what LLMs are good at. I mean, yeah, they are good at idea generation, but if you look at my example of explaining my joke, that was highly constrained, and yet it nailed it, right? So it's perfectly good at constrained other person's idea explanation and understanding. But okay, unconstrained idea generation, what do you have to say about that?
In pretty much every human field, even fields of endeavor, you have this interesting juxtaposition between the creative idea generation and the laborious deductive idea shaking. Okay, even in math, this is true. Fermat came up with this conjecture and of course also claimed that he proved it. And Andrew Weil spent 17 years of his life 200 years later to actually prove that what Fermat was saying is actually, provable with respect to the mathematical axioms, with some math that was invented much later than Fermat, right?
This is kind of funny. It seems like Rao is doing a kind of reversal that I pointed out before. If I give you two different scenarios, scenario number one, some intelligent agent says, hey, look at this equation, a to the n plus b to the n equals c to the n. I wonder if I could conjecture something about it having integer solutions with arbitrarily large values of n. That would be kind of interesting. I wonder. And then scenario two, some other intelligent agent is like, okay, I'm supposed to prove that a to the n plus b to the n equals c to the n doesn't have any solutions under certain values of n. All right, let me just crunch through this. Let me see what it's going to take to prove it. So you have these two phases of the proof, right? Coming up with what to prove and then crunching through and proving it. I feel like most people would want to say, yes, the crunching part is more of the domain of computers and AIs, but look at the creative part. That is uniquely human. So there's a little bit of a reversal now when Rao is saying, look, AI can help you generate this idea that a to the n plus b to the n equals c to the n might be interesting to try to prove, but you need a human to crunch through what the proof is going to be. A little bit of a reversal, right? Now, of course, he's going to argue, well, no, Andrew Wiles, he had to invent new fields of math to prove it. So it's, it's not a great example, but I am detecting a little bit of a funny reversal. Anyway.
Math requires both the creativity as well as deductive thing. And sometimes the same mathematician has both of them. Sometimes it's also the case that some mathematicians are better at the actual proof part and some are better at seeing the creative connection. Ramanujan, the guy from India, is like the most famous of his lot because he seemed to have had a creative generator that almost had a much higher density of being correct. And so he would just write these huge, crazy series and write the answer with no proof. And, G.H. Hardy basically famously said they must be true because if they weren't, nobody would have the imagination to write this. He was obviously being facetious.
Actually, no, he wasn't being facetious. What he just said about Ramanujan's conjectures, some of them being so brilliantly inspired that how could they not be correct? That's largely true. That's actually an important insight. It applies to science too. When Einstein came up with the special and general theories of relativity, his attitude was like, look, this math fits so well to the constraints that I needed it to fit. It's very likely right. You guys can go do your experiments, but I know this is right because it's so over-constrained. When I found something that fits my constraints, this was so hard to find and so unique among what it could possibly be that I think I got it, guys. I think this is it. And it's the same thing, presumably, with the search process that happened inside of Ramanujan's brilliant subconscious brain. He's plucking out these conjectures that the amount of constraints they had to satisfy to get promoted to something Ramanujan would conjecture, he's already done a lot of the work. He's already traversed a lot of the bits of Bayesian evidence that you need, promoting a hypothesis, locating it in the space of possible hypotheses. A lot of times you've collected enough bits of evidence just to know what hypothesis to say, that the extra bits of evidence you then need from your environment to promote it all the way to being super sure about it, those last few bits, yeah, those are important, but there's still a small fraction of all the evidence you've already collected to even know that you should name that hypothesis. So in the case of Einstein coming up with theory of relativity, most of the Bayesian evidence that he needed to believe that the theory of relativity was a true description of observation, he already had those bits even before the first experiment was conducted. This is actually a correct description of how superintelligences reason. It's okay to have this much evidence before you collect empirical data. So that part of what G.H. Hardy is saying seems to have gone over Rao's head because he called it being facetious. I really think that he's missing something here. And it's the same thing with Claude explaining my joke, right? So the fact that it nailed this one problem, to me, gives me very strong evidence that it has what it takes to nail many problems. And if you vary the problem and show it getting it wrong, like I keep repeating, that does not undo the amount of evidence that I gained by seeing it do one problem of this level of complexity right. You do not get one problem of this level of complexity right by coincidence. Again, that's the crux of our disagreement, Rao.
In general, the creativity part is something that LLMs are extremely good at.
There's that funny reversal again. Rao is so intent on telling us that AIs can't reason that he's giving away okay, yeah, so they're great at this creativity thing. Okay, so now they're just creative. And actually, to use his precise language before, he said unconstrained idea generation is the sense in which they're creative, right? So it has to be unconstrained and it has to be generation. Okay, but then if he's comparing it to the example of Ramanujan and Fermat coming up with conjectures of things to prove, is that really unconstrained? Because these guys have a high hit rate, right? So it's not just hey, dump out any mathematical proposition. No, it's dump out a mathematical proposition that seems sufficiently high probability of being true, even though how interesting it is. And that is quite a showcase of what you call unconstrained idea generation. I would argue that having a high likelihood of being true is a huge constraint that you're calling unconstrained idea generation, right? And now you're saying okay, well, it's creatively coming up with these propositions. It's and you're telling me this isn't reasoning? It's just popping out these propositions that have a super high probability of being true and aren't found in any previous textbooks? This is your boundary that you're saying LLMs can do versus things that they can't do? They can just be geniuses at telling you mathematical propositions that have an unusually high chance of being true? I'm pretty confused.
There's nothing wrong with having ideas. The only thing that civilization needs is that when you get the idea, you check whether the idea works. That's the robustness aspect. If it doesn't work, you give up on this idea, go for something else. And we typically find that verification of an idea is easier, having the idea is harder.
Okay, what Rao is saying now, I think he is actually confusing himself because he's invoking this idea of P versus NP, the idea that oftentimes finding a solution to a problem can be really hard, but then once you've got the solution, verifying it is easy. And he's making a connection, he made it earlier to like, hey, look at Fermat's last theorem. It was relatively easy for Fermat to kind of have the brainwave of like, oh, this would be fun to prove. But then Andrew Wiles had to spend like 17 years and invent new math, and it was actually really hard for him to prove. And originally, Rao's point was that AI could have helped do stuff like what Fermat did. It could have helped generate these ideas for cool things to prove. And then it takes a real human genius who can reason to search through the space of possible proofs and prove that theorem. Because stating a theorem, that's not the hard search problem. The hard search problem is actually searching through the space of proofs and finding a valid proof. And then you get an easy verification problem, which is to go step by step through the proof as written and verify that the found proof is a correct proof, right? So there's three different steps, right? There's coming up with a conjecture that you think would be cool to try to prove. And then there's doing all that hard work and labor, a creative labor of finding a proof if you can, or maybe proving its negation. And then the third step is the easy step of just reading through the proof and verifying that, like, yes, this is a proof. I think he's getting himself confused because, Rao, what exactly is the part that AI can easily do versus the part that AI can't do? Because back when we were talking about Fermat's last theorem, you made it sound like, yes, AI can help generate the theorem. AI cannot search the space of possible proofs. But what are you saying now about what AI can do and what humans can do?
In fact, in our lifetime, in our lives, we would have friends sometimes who are fount of ideas. So you get stuck, you ask, hey, Tom, do you have an idea on how to do this? Tom may not have a big stake in this, but they are good at generating ideas. They'll give an idea, and it's your responsibility to check if it actually works. And when it does work, we tend to give much more credit to Tom because Tom gave the idea. But Tom didn't prove that the idea was right. Okay, you proved it. And it's easy for us to kind of verify, and we think idea generation is the more important thing. LLMs are actually good for the idea generation, and they're actually bad for the thing that is easy for us to some extent, which is verification.
Yeah, I'm still confused. In the example with Tom, okay, Tom threw out a conjecture. And then for you to find a proof of Tom's conjecture in general is a very hard search problem. So you put in that sweat, right? You solve this potentially exponentially sized search space problem. And then, once you solved it, you can show your proof to people like Tom and they can easily verify it. So maybe Tom had some way to easily throw out potential candidate things you could prove. And then Tom had no problem verifying your proof because proofs are easily verifiable. Okay, but is the hardest thing in this whole interaction your own sweat, your own search for a proof? I think Rao is getting confused and he's starting to use the term verification in the context of like, oh yeah, you verified Tom's conjecture by searching for a proof of it, right? So that, I feel like he's confusing himself.
LLMs are actually good for the idea generation, and they're actually bad for the thing that is easy for us to some extent, which is verification.
I don't think he meant to say LLMs are bad at verification. I think he meant to say LLMs are bad at doing the logical search work, right? At searching the exponentially branching tree of possible logical proofs. Okay, LLMs are bad at that. I think that was his point. And then he started getting confused and saying LLMs are bad at verification, which is something that should be easy for everybody.
And so in general, that sort of the creativity part is making the inductive leaps to cut down the search, so that if you just make an idea and you don't actually check if it works, then it's just an idea. Okay. But then once you can, if you have hopefully a generator of ideas that has a higher density of good ideas, it can reduce the search quite significantly in terms of, and so that's sort of the way creativity and the reasoning come together. So inductive versus deductive leaps, right? An inductive leap versus deductive closure. Okay. The inductive leaps basically are all the imagination, all the creativity part. And LLMs are actually quite good at some of those things because it's no skin off their nose. They're giving you ideas. You ask and they will give you ideas. But you have to check whether that idea actually makes sense in the context of all the constraints of the problem.
If I have a problem I want to solve, and there's a lot of different constraints as part of the problem, and somebody threw out an idea that I want to check, and I just take that idea and I just put it into an LLM prompt. I write the idea, I write all the different constraints that it has to solve, I write the problem, and I ask the LLM, hey, what do you think? Do you think this idea might be plausible with these constraints? Why shouldn't we expect the LLM to give us a pretty good answer? Why shouldn't we expect the LLM to work with all of these constraints? I mean, when it analyzed my joke, it was working under a lot of constraints. I was like, hey, I wrote something. I think it's funny. There's some connection here. Find the connection. Tell me what it is. Tell me why it's funny, right? I mean, what's fundamentally the problem here? I think before, Rao was trying to say, well, the problem is that if there's a logical deductive search involved, LLMs aren't good at that. But he's kind of talked himself into this other claim where it's like, oh, I bet it's going to have a hard time verifying if a candidate creative solution obeys enough constraints. Like, what are you talking about? Like, what is the fundamental distinction here? I'm completely confused.
In general, people in like more creative fields, like things like design and like engineering design, which straddle the creativity aspect as well as the realizability aspect. Architecture is another one. They tend to almost say that during the ideation phase, you need to be unconstrained. And then once you get good ideas, then you have to make sure that actually the building which looks like that can be supported with the kind of strengths of materials that we currently have. Otherwise, it's just a beautiful looking building that you cannot build it. And so this second part is equally important. And, one of the hope is when people, do architecture courses, let's say, they tend to constrain their generator, their ideation phase, such that they're more likely to come up with, ideas which are likely to be realizable.
Okay, I still have no idea how he would analyze the creativity and the reasoning involved in suggesting something like the conjecture of Fermat's last theorem. Because these kind of conjectures are only interesting when your hit rate isn't just 50%, right? The thing about Fermat's last theorem is that the statement of the theorem, a to the n plus b to the n equals c to the n. I mean, the way the formula looks, it looks like it's taken out of God's book of formulas that might be true. The mathematician Paul Erdős talks about like God's book of elegant proofs. It's such an elegant statement, and it seems like you're really learning something about math if you learn that that is true. A typical proposition might sound more like this. Hey, I bet there are infinitely many primes p such that p plus 1 is divisible by the sum of the digits of p. That's kind of cool, but whether you learn the answers one way or the other, it just doesn't feel like you've learned quite as much about numbers as you have when you look at Fermat's last theorem, because like, okay, some of their digits, that might be kind of contingent on base 10. It might just be like some random trick. It's probably going to be easy to prove. And that's the thing about Fermat's last theorem. The very fact that it turned out to be really hard to prove, that actually is evidence of like how important it is, right? Like how much underlying structure it must have, that it's kind of like on the borderline of like, you can imagine that number theory is almost willing to let it be false, right? It's not hell-bent on making it true. I don't know. They're just, it feels like there's something very significant about it. Like if it's a candidate for the G.H. Hardy reaction of like, wow, the fact that you even thought to scrawl this in the margin, to me makes me feel like you're onto something, right? There's something a little bit more special about that than the sum of the prime digits thing that I just said, where I really just pulled it out of my butt. I'm like, okay, yeah, adding digits together, whatever. Anyway, back to my confusion about Rao. Rao keeps talking about how cool it is to creatively generate candidate hypotheses, but he's not explicitly addressing the hit rate that we need out of these hypotheses, right? Because if you have a very, very low hit rate, what use is the creativity? The creativity is useful to the degree that the hit rate is high. Imagine that you're trying to write a research paper and you're trying to get your PhD or you're trying to get published, and you've got this helpful assistant. The job of the assistant is to do what Rao says the AI assistant is good at, which is to generate candidate hypotheses that you can then prove and you can verify the proof. Its job is to be the creative one, according to Rao. But the problem is every time it spits something out for you, you start working on it and you realize it's a dud. And this happens like 1,000 times. Either it's like trivial to prove true or false, or maybe it's like too hard to prove true. And if you do manage to prove true, it's just like an ugly proof that doesn't deserve to make it in the research paper. Like, the point is, in some sense, you've got this creative generator, but the hit rate of what you need is low. I feel like that undermines what Rao is claiming, that these creative systems are useful. So I think there's a hidden assumption in what Rao's saying, which is that like, okay, sure, yeah, AI can be creative as long as it's unconstrained, but wait, no, it is constrained. Like, there's some useful constraint that you're giving it that it's hitting. It's hitting a target, right? And then is he claiming that hitting a target is merely creative, but it's not reasoning? Like, you don't think there's some underlying reasoning going on that's enabling the AI to consistently hit a target in a scenario where it's hitting a target, right? Like, this important kind of discussion seems to be totally missing from Rao's analysis, right? He seems to be leaning on this distinction where you can have a system that's just unconstrained idea generation, but he's not acknowledging, wait a minute, if it's fully unconstrained, it's not useful. If it's useful, then it must be operating under some constraints, right? He's not addressing that.
That's my way of looking at where the creativity and the reasoning part come in, and it's very relevant with LLMs, because I would use LLMs for their creative things, because mostly because ideas require knowledge. It's like ideation requires shallow knowledge of very wide scope.
Idea generation requires shallow knowledge of a wide scope. So when Einstein generated the theory of relativity, that was shallow knowledge of a wide scope. It seems like he had to research pretty deeply into what constraints he was trying to solve, like invent the constraints, explore a bunch of math to figure out which math was able to fit, like Minkowski space, right? Like the particular set of equations that got him all the properties he wanted. You're telling me that was shallow knowledge of a very wide space? It sounds like you're just thinking about certain examples, right? Like, okay, fine. Maybe if I think of a joke, I'm just making connections where I have a shallow understanding of the different things involved. Fine. I agree. Sometimes creativity is a search where the knowledge of the different things you're searching is shallow, of course, but that's not a defining property. That's not a characteristic of creativity, right? It just seems like a convenient thing that is supporting your hand-wavy model, but isn't fundamental to intelligence. So why would you say that, Rao? Like, how confident are you about this assertion? Because if it's a load-bearing assertion of your whole mental model of what creativity is, what reasoning is, if you're that confident that idea generation always makes shallow connections, then we need a new term to define what it is that made Einstein's breakthrough possible, because I don't think you've accurately described it.
Analogies are a great case where LLMs actually do better than normal, people, a man on the street. And to do analogy, you need to have at least a significant amount of knowledge about the world. So if you want to sort of analogize how things in Finland will work, knowing how things in India will work, you need to know something about these countries. And not everybody might know them, so they may not be able to construct those analogies. Whereas LLMs actually have been trained on the entire world's data, and so they can make these kinds of shallow, unguaranteed leaps. And then you have to pick up and check whether or not that thing holds. So that's one great place for them.
Okay, clearly analogies themselves aren't shallow because the deepest thinking is performed by analogies, right? We just call them deep analogies. It sounds like the substantive claim Rao is making now is the claim that LLM thinking is always shallow. Like LLMs never produce output based on deep thinking of any kind, which, if you ask me, it was somewhat deep the way that it interpreted my joke, or like it's somewhat deep the way AIs can process a medical case study, or even just start following the instructions of the factoring algorithm, like not robustly, but the fact that they're starting to follow it, I would call that somewhat deep, right? Like the ability to go step by step, I'd call that somewhat deep. So the only new piece of what Rao is saying here is he's saying, well, of course LLMs are going to be good at some analogies, the shallow ones, because they're shallow pattern matching. They're doing something with statistics and n-grams that are suddenly letting them make analogies work. I think Rao is probably implicitly granting that using vector embeddings is doing a lot of heavy lifting, right? So like in Rao's model of the world, sure, yeah, okay, we've grounded these symbols and we're making analogies, but it's just because vector embeddings are really powerful, right? So like, sure, they kind of locate the true meaning of the word in vector space, but they don't do much beyond that, I feel like, is Rao's position, right? I would be surprised if he didn't grant that they at least do that much. So that's kind of interesting that he's not explicitly acknowledging how amazing that part is, right? He's just skipping over to being able to criticize how little analogical reasoning they do past that point. Anyway.
If you don't mind, I want to just gently push on this creativity thing. So you said that, what was the term you used? Yeah, that's... In order to generate ideas, we need knowledge, but reasoning is about creating new knowledge. And if you think about it, we could just be completely open-ended when we generate our ideas, and that wouldn't be very good. Or it can be guided by intuition or existing knowledge. But I think there's a difference between inventive creativity and combinatorial creativity. So I think there should be some form of reasoning, even in the creativity itself.
Yeah, I mean, if you want to characterize LLMs as only being useful for idea generation, you really have to explain why the hit rate of their idea generation is high, right? I didn't ask Claude to generate ideas for what my joke could mean. I just asked it to give me the best guess, and the best guess was right. And I feel like the best guess is often going to be right on a lot of these jokes. Similarly with a medical diagnosis, if you ask it, hey, give me the top 5 things that might be wrong with me, you're going to get a high hit rate, right? At least as good as any doctor, right? That's what the benchmark is showing, that in a lot of these case studies, they're matching the human doctor at listing things that are correct to diagnose you with, right? So is that unconstrained creativity? Is that shallow analogies? Is that pattern matching? Or is that reasoning, right? The ultimate thing that he doesn't want to admit that AIs can do, right? Is there really such a difference? Because he's carving out things that he's willing to say that they can do, right? He's willing to say that they can do this unconstrained creativity. Like he literally uses the word creativity, right? Whereas if you look at somebody like David Deutsch, he typically says AIs don't create new knowledge and they're not showing true creativity right now. I guess David Deutsch doesn't really use the term reasoning. If I remember, he's more about creating new knowledge and creativity. So we can make like a Venn diagram, right? Like new knowledge, reasoning, creativity, and like different experts who are granting that AIs do or don't have all of these magical terms. Whereas from my perspective, or the Eliezer Yudkowsky perspective, it's really just optimizing, right? You take an input, you try to map it to an output. The output represents a small target in a big search space. If you can do that mapping correctly, and it's not just a trivial algorithm, like the search space does indeed seem very vast, and yet you're navigating it anyway, then you're doing reasoning, you're doing creativity, you're doing intelligence, like all of it just falls out, right? You're basically just doing magic. You're achieving something that is going to give you power over the universe. So that's my preferred framework. It seems really crisp. There's a lot of useful math you can do around it. But no, right? People like Rao have to insist that, okay, it can do creativity, but it can't do reasoning. And Tim Scarf is pushing back in a really useful way. He's saying, well, kind of like what I said, he's like, okay, but if the creativity is useful, you got to figure maybe there's some reasoning happening inside the creativity to power the creativity. And Tim Scarf is suggesting, what if we can carve out 2 types of creativity and we can say that AIs can only do combinatorial creativity, but they can't do inventive creativity. That sounds to me like David Deutsch is create new knowledge, right? So Tim Scarf is just trying to draw a boundary in maybe the same place David Deutsch would draw the boundary, right? Which again, I wouldn't do, but it's an interesting question to put forth to Rao.
And that leads me to think that language models are surely limited in the types of things that they can create because they're bounded by the training data.
I agree, but my point is that compared to you and me, they have been trained on a lot more data, that even if they're doing shallow, almost pattern match across their vast knowledge, to you, it looks very impressive and it's a very useful ability.
As you keep listening to Rao's answer, keep in mind, Tim Scarf is asking him, what type of creativity do they have and what type do they not have? And keep in mind, I showed you an example where I asked Claude to explain the joke and Claude said, The joke implies that McFarland is making a dark, self-deprecating reference on LinkedIn by suggesting that his disastrous festival is no longer the worst music festival in light of the October 7th attack, which occurred during the Supernova Music Festival in Israel. Remember Claude's response to my question and try to connect that, try to see if that squares with what Rao is saying here about what LLMs can and can't do.
There's this very interesting point about whether, in fact, the creativity that a machine creates is considered, as you said, combinatorial versus something beyond. But that becomes almost a second-order question if you don't even have, a tool which actually generates this combinatorial creativity over vast knowledge. That's where they really shine. And for that perspective, I am willing to use them for that creativity aspect. I would almost never use them for reasoning aspect, because reasoning requires some kind of a guarantee that what you said is actually true. And I can't believe that they are not going to be able to do that for at least the usual correctness considerations. They can do it better for style in general. That means they can create an essay that looks more like a well-written English essay, as against making sure that the content of that essay is actually factual, and that there is, and maybe even making interesting deductive closure claims, which is actually going from the premises towards, more interesting. That's the part that I don't believe LLMs can do, but they can write and also check the style of another essay, because that's what they're good at. And to some extent, actually, this is autoregressive LLMs are a specific form of generative AI. And generative AI learns properties of a distribution. Style is a distributional property. Correctness and factuality is a instance level property. And LLMs do very well on the distributional properties because they're distribution learners, and they are not going to give you any guarantees about instance level correctness. And so that we do have other tools for, obviously, and we can put them together.
I didn't detect any connection whatsoever between what Rao just said and the example of explaining my joke. For example, when he talks about distributional properties, how does correctly getting all the references to my joke and explaining them and explaining why the joke is funny, what's the distributional property of that? Or Rao's point about how LLMs can mimic style really well, but they don't get factual content reliably. Okay, well, all of the factual content in its answer to explaining my joke was perfectly on point, right? There were no factual inaccuracies. And what did its response have to do with style? It just wrote it in a good, informative English style. So again, Rao just seems to be talking past this amazing achievement that LLMs are doing, right? I gave you one example. I could give you other examples. Like if you see it, give a really good diagnosis, right? Another one of my favorite examples, medical diagnosis. I don't think what he's saying about style and statistical distribution are going to apply to some of the inferences that it's going to print out when you ask it to make a medical diagnosis. It seems like he's not substantiating some of his claims about these terms and these limitations. He's just not substantiating them with good examples. I'm getting a lot of mileage out of telling you my one example that I was impressed by. So I wish people like Rao would refer to more examples to make their point, because examples of what Claude can do just tend to be quite amazing, quite meaty, quite interesting to dive into. So examples would be helpful.
Yeah, interesting. So it sounds like we're saying there is a verification and reasoning gap and potentially a creativity gap, but the reasoning gap is much bigger. We should focus on that. But the other thing, of course, is that because we're talking about building this mimetic system where humans are engaged. So we're always doing creative things. We produce data. The data goes into the language model. So we're creating this big collective intelligence.
Exactly.
And in a sense, let's say you do something creative tomorrow, it will be in GPT-4.
Yeah, exactly.
Kim is just repeating back Rao's worldview of like, yeah, humans are creative, and then GPT-4 just has a database of all the times when humans were creative. I see this as a shortcoming on Tim's part to not try to think of a counterexample like I just did, right? Just to bring it back to the example of my joke. Like, which previous example of human creativity is allowing GPT-4 or Claude to understand my novel joke, right? A single counterexample would demolish, from my perspective, demolish Rao's claims. But instead of reaching for a counterexample, which I don't even think is that hard, Tim is he's just repeating back what Rao is saying and moving on, right? It's like, let's have some pushback here, Tim.
Many people don't realize, as you very well put just now, that they are scaffolded over our collective knowledge. So I keep asking people to do this thought experiment. Imagine Sam Altman got Satya Nadella to already pay for training GPT-K, right? And he just didn't have web, right? And he had to create the web. And so he comes and says, guys, why don't you just put everything you ever wanted to talk about on the web so that I can use this as a data? That would be dead on arrival because nobody would do that. We made web for each other's to actually, kind of communicate with each other. And that then became fodder for these systems. So in a way, the fact that these things are doing well is very much based on the fact that they are doing shallow pattern matching-ish sorts of things over this vast knowledge that we have put on the web.
It's obviously true that GPT-4 has a deep knowledge of the web. Like, it understands what every web page is about, right? It can spit out a summary, any kind of summary that you want it to make. It uses an actual deep understanding of the meaning of what's on that web page to create the summary, right? There's no shortcut to create the summary. There's no such thing as a shallow way to create the summary. It's not going to create a summary that matches the statistical patterns that you expect from a summary. No, it's going to create, if you say, hey, summarize this in 15 words, it's actually going to project the embedding, right? Do whatever it is that a deep understanding would actually do. Like, there's no way to do something deeper than project an embedding in a high dimensional space. Like, we as humans don't really do something fancier than that. That, as far as I can tell, that seems to be what true understanding looks like, is representing things in these high dimensional space where like the dimensions represent properties at different levels of organization. Like, I think they're onto the magic that the human brain is doing. I don't see a reason to believe that there's extra magic. The extra magic that the human brain is doing that the AI can't follow seems to be in our like system 2. There is some secret sauce with human reasoning that makes human reasoning more robust, right? That's where I see potential secret sauce. I find it interesting that Rao is working in this term shallow, as if being shallow is somehow connected to having this big knowledge base. Yeah, it has a knowledge base that it deeply understands, right? And then when you ask it a question like asking to explain my joke or ask it to explain any joke, the way that it explains the joke is by actually understanding the joke, right? There's no shortcut. If you look at how it explained my joke, where's the shortcut? What did it do differently in how it explained my joke compared to what a human would do? A human would also think, what are the references that I'm making in my joke out of everything I know? What seems like the reference? And you can call it like a shallow statistical match or whatever, but we as humans, a big part of what we do is we use this embedding and we try to search the embeddings we know, right? We also do a similar match, right? And then we try to find a connection. We search our space of possible deep connections to say, what connection is this joke making, right? So everything that the AI has done to explain the joke, to me, seems very deeply connected to what a human would do to explain a joke. And the only way you can write this off is you can be like, well, maybe joke explanation is a fundamentally easy problem, which reminds me of something Stephen Wolfram said when he saw LLMs. He's like, well, I guess using language was just an easier problem than we realized, which to me seems like a cop-out. Like, I don't think it's an easy problem. I think it's a hard problem, and I think we solved it. And I think there's not that many hard problems left, right? That's my perspective. But anyway, in terms of what Rao is saying right now, he seems to be smuggling in this judgmental term, shallow, and he's trying to connect it with the evidence of like, yeah, it just has this big knowledge base. Whereas my point is like, it's not a point against you to just understand knowledge as long as you can successfully apply it the same way a human applies it.
It's very important to remember that they're not creating this. In fact, if you make them create knowledge,
he said creating new knowledge. So now he's got all three terms on my AGI skeptic bingo card, right? He talked about reasoning, he talked about creativity, now he's talking about creating new knowledge. Let's listen.
If you make them create knowledge, create kind of text, and my biggest worry is, I actually said this, that, in Norway, there is this seed vault. And they basically have a vault in somewhere high up in northern Norway where they kept all the seeds of the things just in case there's some nuclear this thing, etc. And we need to restart the civilization. You have seeds there. And I always felt that we need to take a snapshot of our current web and put it in that seed vault, because as LLMs generate more and more completions and they become part of the web, essentially you are now have a much more noisier version than things like Wikipedia and New York Times, etc., which are a lot more curated kinds of sources. And when it's all combined, it becomes much harder.
Okay, false alarm. When he said make the LLMs create new knowledge, I think he was just saying when you make the LLMs output whatever text they're going to output, it's going to pollute our corpus of human-generated text. So I don't actually think he was explaining a scenario where he thinks the LLMs are creating new knowledge. So I think he just never really addresses what does that mean to create new knowledge. I think he just sticks to talking about reasoning and talking about creativity. He just happened to say the words create new knowledge, but he's back to saying, well, anything that an LLM could ever produce is just going to be statistical slop. It's not going to add value. For instance, if an LLM explains my joke, he doesn't think that can add value to add that into the internet because it's probably just going to be redundant with other knowledge that's already on the internet, or maybe it could be equally likely to be wrong as right. So it's like too risky to put it on the internet. This kind of implies that this whole idea of synthetic data is worthless in his mind, right? I'm putting words in his mouth, but if you take his worldview, you might conclude that there's no point in having LLMs generate a bunch of training data for other LLMs, even if they took a bunch of computational time to come up with their data. Like, oh, here's a corpus of joke explanations that I've written based on unexplained jokes I've seen on the internet. From Rao's perspective, that would just be like too sloppy, right? Too much like AI slop to be productive in training the next generation, something like that. I mean, I'm just trying to extrapolate what he's saying. Let's keep listening.
So when people talk about you can somehow, you don't need human data. I mean, not too many smart people say that, but a few, not well-informed people think that somehow, why can't LLMs just create data and train themselves? That's essentially blind leading the blind.
Yep. Looks like I passed the ideological Turing test for Rao. I correctly predicted that somebody with his worldview would be very down on synthetic data. It wasn't really hard to predict, but let's see what else he says about synthetic data.
It's actually becomes much worse because, the completions are only the distribution. They're not really have any kind of an accuracy. And so the factuality goes even more down.
It's killing me that he's continuing to make statements like, the AI's completions are only the statistical distribution of the data that you gave it. Like, okay, explaining my joke where I put together these two music festivals and, found gallows humor in it, that was just a statistical completion, really. And so it doesn't add any value when you show a version of the joke and then the explained version of the joke. That's just worthless as additional data. Like no reasoning took place. Just a crazy worldview.
And when people talk about synthetic data, typically what they'll wind up doing is they'll depend on some external solver which actually produces the synthetic data with guarantees. So if I want to kind of do better planning, I will create a huge number of planning problems, use an existing outside planner to solve them, and then now have the problem and the plan. I fine-tune my LLM so that it sort of becomes slightly better at generating solutions for this distribution of planning problems. If it just generates plans itself and trains itself, that would be, blind leading the blind.
That makes sense. Rao and I both agree that if you take a non-LLM type of AI, like some sort of logical solver, right, like something that computes the best chess position, not just using LLM internals, but using more of a game tree lookup or maybe something like a mathematical proof finder, right? Things that you don't traditionally think of as LLM strengths, even a Python interpreter, right? Things that are like more old-fashioned, neat, structured AI. Maybe the outputs of that kind of structured AI can then feed into the LLM's quote-unquote intuition, right? It can feed into its system one. That's a familiar experience for us humans, right? So for example, I'm an amateur piano player, like I mentioned. If I'm playing a bunch of music that was written by the greats, where I could never hope to compose something like a Bach fugue, right? That's way beyond my level of understanding why that sounds good. But I'm playing so many of these Bach pieces that my fingers are just starting to get the pattern, right? Something in my layers of organization of system one, where even though I'm not architected like the genius that can solve how to build this kind of music, I can still get the hang of playing it and even subconsciously predict what kind of chords are coming next because I'm so used to it. I'm so used to matching shallower patterns, even without deeply understanding how to generate the music. So I think Rao and I agree that this is a pretty good description of how synthetic data by some kind of non-LLM structured AI can still be helpful to making the LLM perform better. The only difference between me and Rao is that Rao kind of doesn't give the LLMs enough credit. He's like, yeah, they're just always coasting, right? They never have like that extra flash of insight, that extra reasoning step where they go, oh, wait a minute. I'm not just going to say like this totally trivial, obvious thing. I'm actually going to like make a little bit of a leap, right? That's where Rao kind of gets off the train. He kind of thinks like, nope, they never do that. They're always just like smoothing, kernel smoothing, right? It's just all about statistical distributions. That's where we diverge. In this next section, Tim asks Rao about the ARC prize, which stands for Abstraction and Reasoning Corpus. It's a very interesting set of challenges where it shows the AI like a grid of pixels and there's like a certain pattern, and then it sees another grid where the first pattern kind of evolves into another pattern. And the challenge is for the AI to predict the transformation rule, to kind of figure out why these grids are transforming based on some examples without knowing in advance what kind of transformations are allowed. So like each challenge could be a novel transformation. Like one time I saw the transformation was that the colored blocks in the first grid were kind of falling down as if they're under the influence of gravity. But that's just one rule, right? They could be changing color, they could be doing anything. And we as humans can look at it and be like, I wonder if this is the rule, right? It's kind of like an IQ test, but it's been given to the AIs. The inventor of the ARC prize, Francois Chollet, he's pretty confident that current LLMs can't solve it because you need something more human-like to solve the ARC prize. And of course, Rao is going to be kind of on the same page, being like, you're not going to solve the ARC prize with statistical stochastic paratree. You're going to need something else. Let's listen.
Are you familiar with Chollet's ARC challenge?
Yes.
Because that's a great example. So, I mean, I'm friends with Jack Cole and the winning team, and they've done data set generation and test time inference and fine tuning and so on, and they've kind of they've made a whole bunch of transform rules, so the reflections and symmetries and stuff like that. And they're kind of like building up the data distribution, and then they're fine tuning a language model on it. And then another approach is like Ryan Greenblatt's one, where you use it as an idea generator, just like you advocate.
Exactly. So Ryan Greenblatt's one is actually very much this sort of LLM modulo version, because they have Python interpreter. So they generate a huge number of code snippets and then check whether or not those snippets could have generated the right results on essentially like the ARC training data. And that kind of gives them a huge advantage. And it's a very reasonable thing to do. But it's basically the guarantee is coming from this interpreter. As we were talking earlier, formal languages have interpreters, natural languages don't. So by actually converting the whole thing into, I will guess the Python code for solving the ARC challenge, right? You now can depend on the help of the Python interpreter to make sense of whatever you guessed. And you can at least compare the expected output with, what actually output, this particular piece of code is generating. At a level, it is still extremely brute force way, because they're generating huge numbers of combinatorial possibilities, and you have to make sure that it is diverse enough. So in general, this is again similar to the LLM modulo stuff that I talk about, where these are sort of generate test approaches where tester is an external thing which actually can give guarantees.
Yeah, Rao thinks the ARC challenge is a great example of how he talks about LLMs just being these unconstrained idea generators. And you really just need this different type of logical intelligence like the Python interpreter to help make sense, to help kind of verify if their candidate solution is going to work. Okay, Rao, fair enough. But this combination you're describing, right, the generative creative part that gives you a bunch of ideas and the ideas have a surprisingly high chance of being correct, and then the part that lets you check if they're correct, isn't that how the human brain works? I mean, when I personally look at an ARC challenge, I can kind of feel myself doing the same thing. I look at the different squares and I'm like, I wonder what's going on with these squares. What if they're doing this? Would that work? And the only way that I can answer my own question and check if they work is I activate a part of my brain that's more just like step-by-step crunching through rules, kind of like the Python interpreter part of my brain, but it's interpreting my own guess as to what the rule is. Like if the rule is, okay, they just always move down, or okay, the top rightmost square pixel always changes color first. Like whatever kind of rules I invent for myself in the generation stage, I need another step where I'm like, okay, what would that mean, right? If this is the rule, what happens in the next frame? So I'm kind of Python interpreting my own idea, and I don't know the answer. It's not like I have a part of my brain that skips to the end. Maybe John von Neumann does, right? Certain geniuses might subconsciously somehow do this entire process, but I don't feel like I subconsciously do the process. I feel like there's a consciously accessible step, like an introspectable step where I'm like, okay, crunch through, run the Python program that you just wrote for yourself really quick and tell me if it actually outputs what you're seeing in the example. And if it does, then you've kind of solved this puzzle and you're ready to use that same program to predict the output, right? That's like my own inner monologue when I'm solving one of these ARC challenges. So when Rao was saying, hey, look, LLMs are just idea generators, it seems like Rao is willing to entertain the idea that we're getting close to human capabilities here, because what is a human brain but a generator that happens to always be really good at generating ideas that actually have a chance of being correct, even when the idea space is huge. Plus, yes, a verifier, a sanity check, a system two, a robustness thing, right? I think we're all on the same page that the system one part, right? The pattern matching part is getting really good. Maybe the disagreement between me and Rao is just that I think system one is more than quote unquote statistical pattern matching, right? I think that what LLMs are doing, I think the human system one, right? The intuition, like a fireman running into a building, but knowing exactly when something in the building is going to make it collapse, right? This is an example of like a deep intuition, something that's hard to describe with simple rules, but like the aggregate of all your observations somehow goes into this trained model, right? Goes into this function, the system one, and somehow screams at you like, I'm worried the building is going to collapse. Probability of building collapse is high, right? These kind of models, what Ilya says, like the model wants to learn, right? This kind of magical system that we've kind of cracked the code of right now, that we're now scaling up, right? We're now benefiting from scaling laws, and like the mystery is deepening, right? They just keep getting better somehow. And like, yes, it doesn't include the Python interpreter. Like you also have to have the interpreter step. But Rao, don't you see where this is leading? And again, Rao is just like, oh, no. The scaling law isn't doing anything because it's still statistical. I think that is where Rao is like refusing to see observations here, right? Because he has these research papers and they're telling him like, oh, no, we were able to like modify the input and get it to get the answer wrong. So Rao is still entertaining the idea of like, don't worry, these machines that you're scaling up, they're like so limited because the Python interpreter part is helping so much. In this particular example, sure, the Python interpreter is helping, but I think once again, he's neglecting how much the generation part has already narrowed the search. He is acting like, oh yeah, it just spits out every possible Python program, right? Those aren't literally his words, but that's his attitude. Like he's not impressed with how good it is at only spitting out a relatively small handful of plausible Python programs. Like that's the magic, man. It's not the interpreting the Python isn't that impressive. Right? The impressive part is that you even spit out few enough candidate programs that we can then go and check those programs. One does not simply spit out a few plausible candidates in an exponential search space. You got to appreciate what's happening here. Let me replay this part for you because Rao literally referred to what the LLM is doing as brute force.
At a level, it is still extremely brute force way because they're generating huge numbers of combinatorial possibilities.
I haven't even looked into this to tell you how many programs are being generated. I don't know if it's hundreds, thousands, tens of thousands, even hundreds of thousands. What I do know is that the total number of possible short Python programs is 10 to the power of thousands, right? So much larger than the size of the universe. And so the narrowing that's happening is thousands of orders of magnitude. So when that's happening and then you're calling it brute force, how did they narrow it? What did they do to narrow the program space? Right? You're kind of glossing over that and being like, oh yeah, you just kind of try everything. You don't try everything. That's the breakthrough, right? That's why we couldn't do this in 2020. That's why this is the cutting edge. It's because it's not brute force. It's this new magic, right? These giant brains that just scale up the number of neurons, scale up the number of parameters, and somehow they learn. They learn something. They learn levels. They learn relationships. They don't learn freaking statistics. They don't learn freaking linear relationships. Like, this is ridiculous.
And you have to make sure that it is diverse enough and the soundness is guaranteed by the tester. The completeness depends on the generator. And as impressive as LLMs are, there are no guarantees that they're complete.
There's no guarantee that an LLM is complete, meaning it can't necessarily ever output in response to any prompt the perfect solution because the space of perfect solutions is really big. and it doesn't map the entire prompt space to the entire solution space, right? So it maps to certain clusters in solution space, and those clusters don't cover the entire space. Yeah, I mean, that's true about everything, right? I mean, me as a human, if I had my whole life to think about all the different theories of physics, my brain probably isn't going to be complete with respect to finding the correct theory of physics. If you give me my whole life to try to brainstorm how quantum theory and Einstein's relativity can be unified, I will probably never output a research paper that's covering the actual space where the answer lies. The range of what my brain can plausibly output, given my level of math skill and just intelligence overall, you're just not going to see complete coverage of idea space, right? That's true about pretty much every brain. You can use a counting argument to say, look, even in principle, the only way that something can be complete, that something can cover the entire range of possible outputs, is if it's highly sensitive to the prompts, right? Because you have to give it like a huge range of possible prompts. You can't have more outputs than there are prompts. Anyway, the reason I'm getting into the weeds here is because I'm kind of frustrated to hear Rao talk about completeness as if this is like a desirable property. Like, oh yeah, you need completeness. Like, wait a minute, what are we really talking about here? Like, this is kind of a difficult framing to work with. In contrast, the framing I like to work with is, are we optimizing toward the target? Are we getting closer? Is the arrow getting closer to the bullseye? Is that happening, yes or no? And then it's pretty obvious the answer is yes, right? The ARC prize, using a combination of LLMs and Python interpreters, something that wasn't possible a few years ago, every week, every month, I'm watching Twitter and I'm seeing tweets, oh, it got closer to the ARC prize. And this has never been possible before. So even if you don't understand how it's happening, even if you want to hand wave it away and say it's not truly intelligent, the arrow keeps getting closer to the bullseye, and it couldn't before. And the range of possible bullseyes that the arrow is able to get closer to, that range keeps growing. We keep hitting more bullseyes. So again, you're always going to have the Raos of the world turning around and saying, ah, yes, it's not complete. It's not truly intelligent. It needs to use a Python interpreter. Okay, but the world's getting swallowed, Rao. Do you have anything to say about that? Do you have a prediction as to when it's going to stop? A falsifiable prediction? Anything? Are you just going to keep skidding and skidding in this game of tug of war, right? You're just going to keep getting tugged. You're going to keep skidding and keep pulling on the rope until you just fall into the ditch. That's what's going to happen.
This is sort of goes back to this issue of, yes, they're creative, but can they create every possible thing? And in general, that almost requires a prompt diversification strategies, where you bring in extra outside knowledge to tell them, okay, now stop generating this kind of code, generate this other kind of code. Because you're then introducing some sort of an inductive bias saying, I believe that, you should also consider this other kind of code because maybe one of them might actually pass the verifier test. That is this extra knowledge that you're bringing in. This old idea, this idea of tree of thoughts that, basically people, that's become very popular, actually is best understood in that way because it's really a prompt diversification strategy which brings in external knowledge to push the LLM.
Okay, Rao, good commentary. So does this mean that the ARC prize will be solved in 2025 or not? What are you implying? I feel like Rao's answer would be like, well, if you did enough prompt diversification, then you would hack your way to a solution, right? So I feel like I'm speculating here, but I feel like Rao's MO is just going to be to brace himself to just explain whatever outcome happens in terms of how he likes to frame the world. So he loves framing the world as if LLMs are just statistical, just pattern matching. And so to the extent that they will actually win the ARC prize in 2025 because they keep getting closer, I'm sure Rao will have some reason why that is consistent with his worldview because they just used prompt diversification, like they automated the prompt diversification piece, and then they automated the checking piece, and then the LLM didn't really do much. It was just brute forcing everything. And then the ARC prize got solved, and the ARC prize has been unsolvable until now, right? So that's kind of Rao's worldview. So like, how is this helpful, Rao? Like, this doesn't seem to have much predictive power, right? This doesn't seem to actually be drawing a barrier between what AIs can and can't do. Like, maybe he'd be like, oh, there is a barrier. There's a barrier between what the LLM module can do and what the other modules around it can do. Maybe there's something to that. I mean, system 1, system 2, like I agree there's some useful things that you can say about that. But again, the important question is, where is AI progress going, right? I feel like there's a Mott and Bailey going on here, where the Mott, the part he says that's well defended is like, look, LLMs aren't that good at logic right now, so they need to be augmented with systems that can check their logic, similar to human system 1 and system 2, right? I feel like I turn on the logical part of my brain, to check the pattern matching part of my brain. That's kind of the mott. And then the Bailey is AI is not going to take over. You're not going to have systems that can overpower humanity because it's all statistical. But wait a minute, no, you didn't say when we were in the mott, you didn't say that it was all statistical. You said that part of it isn't capable of doing logic very well and needs to be augmented. But then you can draw a box around the system as a whole, and suddenly you're getting the solution to the ARC prize, right? You're getting self-driving cars. You're just getting everything. You're getting really good, insightful joke explanations. You're getting them doing an entire job. You're getting them being the CEO of a company, right? Like, where does it end, Rao? What predictive power can you tell us about where it ends, right? The Bailey of people like Rao seems to be that, Mark Andreessen and Martin Casado go on a podcast and say, everything is going to be great. You don't have to worry about AI, right? That's their Bailey. And then they go to the mott and they say, hey, look, here's a research paper that says all LLMs do is kernel smoothing. And they act like those two things are connected, the mott and the Bailey.
Yeah, so I interviewed Ryan Greenblatt, and unfortunately he still thinks that, because obviously I asserted that it's, you've got a system 1 and system 2, you've got a neurosymbolic model, it's only working because you have the Python interpreter, verifying. And he was adamant that, no, just wait until the next GPT model comes along, it's going to, but the beautiful segue is that he did a few things, right? He did chain of thought. So, he carved up the space. He did self-reflection, so refinement of the solutions. And he believes deep in his bones that the LLM can autonomously verify itself and come up with the right solution.
Yeah.
Okay, you're talking about the guy who pushed the frontier of the highest score of the ARC challenge, right? This guy's a winner. He has empirical validation for his worldview. And he's telling you that he thinks the LLMs are really grasping the challenge, right? They're doing most of the work of doing the challenge. They're not just brute forcing, right? They're not just unconstrainedly generating a bunch of random statistical Python programs. No, they're just understanding what would be a good guess. The same thing that I describe my own brain as doing. So, people always say, oh, if you truly understand AI, you won't be worried about where it's going. Here's a guy who has empirical proof. He's getting the results, right? So people like Rao will speculate about how, oh, these are so limited. And then people like Ryan Greenblatt will be like, okay, I just passed the next challenge. What's next? Give me another challenge. So Rao is in this position where he has to look at the Ryan Greenblatts of the world who are just charging forward and demonstrating empirical results, even on challenges specifically designed to show what they can't do. And they're plowing through those challenges anyway, right? The ARC prize is now predicted to fall in about a year and a half. Like, that's what people are predicting, even though it's supposed to be this challenge that shows what today's AIs fundamentally can't do. And yet, one way or the other, the Ryan Greenblatts of the world are going to take it down. So it keeps supporting what I'm saying about Rao, which is he's the guy holding the rope in a tug of war who's getting tugged into a ditch, but he's still, he's still holding on. He's still facing the other way, being like, no. It's not tugging. Like, the rope is actually not getting tugged very hard, or like other things are tugging the rope. But he's getting pulled into the ditch. And once he's in the ditch, once AI overpowers humanity, it's going to be too late to be like, you know what? I was probably not saying useful stuff on all those podcasts. I really should have focused on how my results are like limited in scope and they don't really give you the accurate impression of what to expect from AI next, right? When humanity is overtaken, it's going to be too late for Rao to take the blame for the approach he's taking now. In this next part, Rao makes a distinction between correctness and style. And he argues that LLMs aren't good at getting things correct and checking themselves whether they've gotten something correct to make sure it's robustly correct, which I kind of agree with, right? I'm always saying, hey, they're not robust enough. That's what's missing with LLMs today. And then he goes on to say, oh, but on style, they're great. So they've like mastered style and they suck at correctness. I don't like the distinction, but let's listen to how he says it.
There is no simple formal system which can take an essay and say it is correct. Right? Because you're tending to basically look at the kind of a style characteristics rather than, in fact, if you have a beautifully written essay, which at some point of time has a fatal factual flaw, they're not going to be able to find it. Right? And yet, if in fact, then basically what they'll do in these cases, they will do human subject studies. And you ask humans, are these better essays versus worse essays? And they might find that somehow the essay quality has improved with the LLM critiquing itself. But that's the style improvement, not the correctness improvement. One of the interesting things is you could have a correct plan that doesn't have the right style. So I give this example of a correct travel plan to come to Vienna from India, where I started, is walk 1 mile, run for another mile, then bike for another mile, etc., etc. By the end of which, indefinite number of these actions, I will be in Vienna. That is sort of correct, but it is highly bad style. Most people would not consider that as a reasonable travel plan because they tend to stick to like an airline flying or some other kind of, standardized versions. So the style is something that LLMs are actually better at critiquing. The correctness is something that they cannot, and you want the external verifiers. And it's a complementary thing because classical AI systems are actually much better at correctness than style.
If you actually think about Rao's scenario, run 1 mile, bike 1 mile, walk 1 mile, run 1 mile, is that really a style issue? That seems like a profoundly wrong answer, right? I mean, if biking 10 miles is a fast and usable option, then why would you stop and walk? That's going to be a slower journey. What criterion are you optimizing for where that kind of switch of medium is helpful? If there's a bridge where you have to walk your bike, and as a result it says, bike 1 mile, walk 1 mile because there's a bridge, bike 1 mile again, then suddenly there's no style issue, right? It's just correct. It found a good answer. So I find it interesting whenever somebody gives an example and then their own example doesn't seem to be making a strong point here, right? I mean, I get what he's trying to say, that it's kind of a shallower property, right? If you're switching between transportation methods and people don't really expect it, LLMs can notice shallower properties. I feel like, because that's always his MO, is to be like, oh yeah, LLMs always just do things that you can notice in the blink of an eye because they're shallow and they're statistical. I get what he's trying to say, but the fundamental distinction between correctness and style, there is no fundamental distinction. An essay with a good style, that's part of having a correct essay. Like, however you want to define what constraints make a good essay, one of those constraints is, for instance, being readable to humans, being logically organized. What he's calling style, from my perspective, are constraints that make something correct in its own domain, right? There are some domains where you characterize the correctness constraint as being style constraints. But like, I could design a computer chip, which you normally don't think of as a style thing. You normally think about it more as a correctness thing. But I could always just arbitrarily characterize, oh, that layout is so beautiful, it has a nice style, right? So we're not talking about a fundamental distinction here. Like, it's correctness all the way down, right? It's constraint satisfaction all the way down. It's scoring metrics all the way down. So when Rao takes his correctness versus style distinction and he goes on to say, LLMs are never going to get you correctness, they just get you style, and you need a different system to get you correctness, he's neglecting what LLMs are doing, which is they're outputting things that not only have the correct style, but they have a good shot at being correct, right? They're not just brute forcing every possible output. They're actually narrowing down things that are both the right style and likely to be correct, right? That's the optimization work being done that he is just not acknowledging, right? Like, there's this amazing feat of magic happening, right? There's complex joke explanation happening in front of his eyes, and he's not putting his finger on why it's amazing. So in my mind, he doesn't have the credibility to be dissing LLMs constantly the way he's doing, when he can't even tell you how big of a miracle it is and why it's a miracle, right? What it's doing that's amazing. He hasn't put it into words.
Yeah, I mean, I agree with you. So I'm kind of like a philosophical rationalist. I think we should be reasoning in the domain of certainty. It's either correct or it's not correct.
I guess I'm not a philosophical rationalist then. I guess I'm a Bayesian rationalist, but go on.
So we agree with that. But devil's advocate for a second, there are folks who think we can do end-to-end predictive models and we can do this active inference and we can just keep leaning into the test instance and fine-tuning and fine-tuning and fine-tuning. And then, we can't verify it. We don't know that it's correct, but we can build systems that work, reasonably robustly and produce often the correct answers.
I like that Tim's asking this question. He's basically asking Rao, look, can't we just keep improving the LLMs and keep making them do useful things until they consume every task? And like, realistically, when you put them in a job, can't they just do the job? Because like, sure, occasionally you'll find some flaw that they can't do perfectly, but they'll just keep eating more and more of your job. And in practice, their accuracy rate will just keep getting higher and higher. And it's going to be so low that it's going to get below like the human accident rate, right? Which is already happening with like self-driving in San Francisco, right? Waymo. I can nitpick how Tim is describing the situation. Tim is saying, they'll never know for sure that they're doing the right thing, but they'll just do it anyway and it'll be good enough. I would nitpick that and I'd be like, well, they're going to just develop strategies for using external tools to check on themselves to the degree that humans can. right? I mean, if you look at most humans in most jobs, it's not like they're that good at standing back and reflecting on themselves and being like, did I really do a great job today? Did I make all good decisions? I mean, they can do it to some degree, but it's not like they're geniuses at that, right? Like they have like a bag of tools. They have certain procedures that they use to reflect on their own work. And I think the system one of the AI, or like whatever magic it's doing, it's just going to get magically good at copying humans at the same kind of procedures that they use to convince themselves that they've done a good job, right? And the only way to do better might be to have like a genius reflect on like the whole organization, like have Elon Musk, fire 80% of the team and like rethink everything from first principles, right? But that's just not what we normally expect from humans, right? That's like doing something extra. So anyway, maybe a small nitpick in Tim's question, but let's hear Rao's response.
Do you think that that's a reasonable thing?
Yeah, I think the point there is, first of all, the end-to-end correctness. You can use the world itself as a verifier.
Yeah, that's actually a really great point. The reason why we just have these big pattern matching system ones in our head and we can just be really effective even without doing that much reasoning is because we constantly get feedback when we like do stuff and then we like look at what we just did, and that gives us a lot of signal about the logical causal consequences of what we just did, and then we can iterate, right? So that's actually a powerful feedback loop, a powerful supplement between the logic of external physics and the pattern matching that we're doing in our pattern matching brain.
Right. And that is an idea that works only in ergodic domains where, in fact, the agent doesn't die, when it's actually trying its bad idea.
Yep. Another great point. When we think of something as, oh, it's just this iterative thing we're going to work on in the real world, sometimes what we're actually doing is fucking around and we're going to find out. So good point.
So even when you're doing end-to-end verification, there needs to be a signal as to whether the output is actually correct. Where is that signal coming from? In general, you would like to have an advice taker to whom you can give very high level advice and they will follow it, right? In general. And chain of thought makes it look like LLMs can do that. But what they really wind up doing is, if you, for example, tell them how to solve like a 3-4 block stacking problems, they actually improve their performance on the 3-4 block stacking problems. But you increase the number of blocks, the principle remains the same. In particular, for example, one chain of thought idea is, in the blocks world, you can always put all the blocks on the table and then just construct the stacks as you need in the goal state. If I sell this to a kid, they understand this, and then they can do it for 1 block or 15 blocks or 200 blocks until they get bored. But LLMs basically don't get the procedure. They only do better for the 3-4 stacks, and then as you increase the number of blocks, they die.
Nope, sorry, I don't think that's the case. I'm sure Rao is referring to some kind of research paper by himself or somebody else. And I'm sure that within that paper is some contrived example where they, tweaked the LLM's input and the LLM didn't do the thing that seems obvious to humans. I get it, but I refuse to believe that today's state-of-the-art LLMs, you can't just put an instruction in their memory like, hey, when you're thinking through how to do this problem, if it's a block world problem, just make sure you get all the blocks on the table first before proceeding. I refuse to believe that there's no reasonable configuration of such an LLM that's, maybe slightly tweaked, but not like super contrived. I refuse to believe that I can't set up something reasonable where the LLM won't follow my instruction to first put the virtual blocks on the table. I refuse to believe it, Rao. If you want to convince me, pull up ChatGPT, pull up a reasonable system and show me how hard it's choking. I get that they sometimes choke, but they don't choke that hard. And I think it's leveraging these kind of contrived examples that I'm claiming is contrived, right? Go ahead and prove me wrong, viewers, if you think I'm misrepresenting him. But I think he's leveraging contrived examples to take away these huge achievements of these LLMs. Now, I also know a type of pushback that he likes to give is he likes to say, oh, sure, yeah, the prompter is the really intelligent one because the prompter will just keep changing the prompt until he gets what he wants. I get it. I'm still just willing to die on this hill of saying, nope, LLMs can, in fact, listen to the advice of putting the blocks on the table first. Like, it is more accurate to say they can than to say they can't. So open challenge, anybody can come fight me or prove me wrong, but that's my claim. The reason I'm so confident is because I see how Claude has mastered the basic operations of this type of problem. So here's Claude 3.5 Sonnet. I just typed, hey, Claude, when I asked you block problems, the first step should be to move all the blocks to be flat on the table. And then I continue, there's a tower on the left, a triangle block is sitting on a rectangle block on a circle block. There's a tower on the right. A red block is sitting on a green block on a blue block. Explain step-by-step operations to swap the position of the rectangle block and the green block, so basically the two middle blocks. So Claude answers, let me first quote and understand the initial setup and constraints. 2 towers, left and right. Left tower bottom to top, circle, rectangle, triangle. That's correct. Right tower bottom to top, blue, green, red. Again, that's correct. Goals, swap the rectangle block and the green block, correct. Constraint, first move all the blocks to the table. So it perfectly took the constraint that I mentioned and put it under the label constraint. So like, it's totally just understanding what I'm saying, right? Like there's no trick here. This is what real understanding looks like, the ability to do this, right? This is not statistically somebody writes the word constraint with a colon and then talks about what they do first next to it. This isn't freaking statistics, okay? All right, so Claude continues, let me solve this step by step. Deconstruct the left tower, remove triangle from rectangle, remove rectangle from circle, correct. Deconstruct the right tower, remove red from green, remove green from blue, correct. Now all blocks are flat on the table in order, circle, rectangle, triangle, blue, green, red, correct. Build a new left tower, place green on circle, place triangle on green, correct. Build the new right tower, place rectangle on blue, place red on rectangle, yep, correct. Final result, left tower bottom to top, circle, green, triangle, correct. Right tower bottom to top, blue, rectangle, red, correct. The swap is complete. Would you like me to clarify any of these steps? No, Claude, I'm happy with your answer. Right, it just correctly nailed everything. When you look at Claude performing something like this perfectly, it's natural and accurate to say, hey, okay, look, yeah, it's good at this like toy problem, but the moment the problem starts getting bigger or more complicated, the moment you tell it to, hey, simulate this Python program without using Python, it starts to become less robust, right? It starts to break down. It starts to not notice its mistakes. Fine. But if you look at you and me as humans, right? I don't know about you, but when I was saying correct, I already had to read the problem beforehand and like spend a minute actually checking if it was correct, right? It took me a little brain power to be like green on circle, triangle on green, right? Like this took some mental effort for me to check that it even was correct, right? And Claude barfed this out very quickly, right? In seconds. So I'm already starting to reach the limit of what my brain can realistically do. Like, yes, I'm more robust than Claude. I can check over stuff, but it's just like, it's a strain. Right? My brain is not going to stretch that much compared to a problem like this. So when I see Claude just walking on past, having apparently no difficulty with this problem, moving on to more and more advanced problems, I just don't see that many more notches that it can surpass me. Like, I think that it's very easy for me to imagine in a year or two that I could be talking to Claude and it could just robustly get like huge problems right? And then I'd be painstakingly checking and I'd be like, yep, as far as I can tell, it's correct. I am no better at checking Claude in 2 years, let's say, than Claude is at checking Claude, right? And so when I hear Rao be like, oh no, when we told it to put blocks on the table and there's 4 blocks, it couldn't do that. I mean, I'm not saying I proved him wrong. Like, I'm sure he has some research paper where the data supports it, but like, he's clearly missing the point. It's like, whatever it is, like that research paper, I'm just going to go on a limb and say it's a bad paper, Rao. Whatever it is, without even looking into detail, I don't like it.
And it turns out it doesn't even need the planning. It actually can be doing, like the last letter concatenation is this much simpler problem where given a couple of words, dog and cat, you want LLMs to say G and T because G is the last letter of dog and T is the last letter of cat. And original COT paper basically said, look, out of the shelf, they can't do it. But if I give this advice about how to do this, they seem to do much better. And we basically did this experiment where we increased the number of words. Having given examples for 2-3 word problems, we increased the number of words. And that should be very reasonable. If you want an AGI, it should at least understand that last letter concatenation is a simple problem where the number of words, you just basically repeat the same thing. It dies. So I keep telling that, this is a sort of the advice taking in general, it sort of reminds me of this old, capitalist the proverb that teach a man how to, give a man fish and you will feed them for a day, and teach a man how to fish, you will feed him for life. And chain of thought acts as if it is a second, but it's actually a weird version of the second where you have to tell LLM how to fish 1 fish, how to fish 2 fish, how to fish 3 fish, etc. At which point you will basically lose patience because it's never learning the actual underlying procedure. It is basically just taking the examples and that of the length that you gave, and it's doing sort of a more or less pattern transfer there as against any sort of procedure learning.
Okay, so again, I'm not going to bother reading Rao's paper, but I am going to have a conversation with Claude. So I message Claude, I say, consider this example. Input, dog, cat, wolf. Output, GTF, the last letter in the words. Now process the following inputs. Input 1, apple, banana, pear. Input 2, sweet, sour, salty. In my conversation with Claude, I didn't even tell Claude we're looking at the last letter. I literally just gave Claude an example, right? Dog, cat, wolf, GTF. Okay, so Claude responds, let me understand the pattern from the example. It appears we need to extract the last letter of each word. Let me process the inputs. Input 1, apple, banana, pear. Output 1, EAR. Yep, that's correct. Input 2, sweet, sour, salty. Output, TRY. Yep, perfectly correct. And then I replied, I said, input 3, Rastafarianism, supercalifragilisticexpialidocious. And Claude said, let me extract the last letter of each word. Input 3, Rastafarianism, supercalifragilisticexpialidocious. Output 3, MS. Okay, so Claude just nailed everything, like better than, as good as the smartest human could do, like 100% perfect. So I'm supposed to believe that there's some paper that says, hey, we tried to make these LLMs better at getting the last letter of the word, and they couldn't, and they didn't follow our advice. So I'm sure that you took GPT-3 or GPT-2 or some weak LLM, or you set up some pathological conditions, right? Like you tweak things so that it failed. I get that, right? I mean, we're both on the same page that this isn't robust. Now you might be like, you know what, Liron, this is your fault here. You're not being intellectually curious. Why don't you just go read the research papers so that you know exactly what Rao's even claiming? No, I will turn the tables and I'll say this isn't my fault for being intellectually lazy. This is actually Rao's fault. Because when he goes on a podcast and says this stuff, okay, most people aren't going to read his paper. And he is taking the results of his paper and generalizing them to be like, oh yeah, these LLMs, they're so fragile, they can't do anything. And that contradicts my everyday experience playing with Claude. So it's really Rao who's just misleading people. Like he's the one who's not addressing the elephant in the room of how is Claude this freaking savvy, this freaking on the ball. And maybe, this is from like 6 months ago. So maybe the answer is just, oh, well, LLMs got better since Rao had this conversation. Fine. But in that case, Rao is kind of misleading everybody by not acknowledging the fact that LLMs might be about to get better, right? I just consider Rao to be almost distributing like disinformation here. I mean, again, I'm sure he's technically right about his paper, but he's just misleading people about what LLMs are so clearly capable of. He's giving the wrong impression, even if he's technically correct.
So a couple of things. I mean, first of all, many of these techniques, they brittle the model in the sense that they make them quite domain specific, even if we do external verification, but also things like RAG and tool use and chain of thought. These things kind of make the models quite domain specific. But the bigger problem I wanted to point out is that we want to teach the models how to fish, but the models don't know how to fish in principle because they're not Turing machines. You gave the example in your paper here of, like a semi-decidable problem, and maybe you should bring that in, but these aren't solvable in principle in language models.
This sounds a lot like a claim that Tim's co-host Keith Duggar likes to make. If you're interested in that type of claim, then I recommend listening to the debate I had on my channel, me versus Keith Duggar, because I really did my best trying to point out that that is like not a good argument, that because LLMs are like finite state automata instead of Turing machines in like a very technical sense, therefore that's going to constrain what they can do. From my perspective, I totally counter-argued against that and basically called it nonsensical. But if you're in the Keith camp, you weren't convinced, right? So there's a faction of people. So maybe you want to join that faction and like continue arguing against me. But if you think the topic is interesting, go watch me versus Keith. But let's continue here with Rao.
So actually, there is an interesting point there that many of the bad ideas in LLMs come because of the wrong connections people make between computational complexity and what LLMs do. Okay. In fact, for example, the very reason why people thought LLMs can be better at verification is generation is typically computationally harder than verification. So they just assumed that maybe they can't do the harder problem, they can do the easier problem.
I'm glad he's self-aware about the funny reversal that I mentioned earlier, right? Because I actually caught that earlier. I was saying, Rao is saying that creativity, like solution generation of solutions that actually have a decent chance of being correct, he's acting like that's an easier problem than verifying the solution is correct. Like he's just letting LLMs have the honor of being like truly creative because he's so intent on making his case that they can't truly reason. I thought it was an unusual choice. So it's nice that he's going to address it head on right now. So tell us, Rao, why can LLMs solve search problems when they struggle with verification?
The reality is they're not computing the solution in any which way. So in fact, as many people have pointed out, if I give, like, consider the following thing. If I have like 5 different prompts, let's say, the one prompt basically implicitly, for those of us who understand English, it's implicitly asking for a solution for a constant time computation problem. Another one is linear time. Another one is polynomial time. And then all the way to another one is undecidable problem. And for all of these, the answer is yes or no, let's say. Except if you want to give the guarantee, you need to actually do the computation. Ask yourself, is LLM going to take more time coming up with the token yes or no, depending on the prompt? No, it basically just takes constant time to come up with the answer. And so people try to say, people basically try to say then that since it's anyway going to give it in constant time, let's make it put out more tokens so that altogether it will take more time.
Yes, obviously you get a weaker model of computation when you only let the LLM output the first token. If I give the LLM a huge number and I say, hey, is this prime? And it's like 1,000 digits long and the LLM's never seen it before. Primality testing is actually known to be in P, so it's actually not going to take like longer than the end of the world. It can actually be done pretty quickly, but it probably can't be done in a single pass of the LLM. Like, you're going to need more steps than that. There's a lower bound on how difficult this problem is. And so there's just no way that in the general case, the LLM is going to correctly output prime or composite when you give it a huge prime like that, right? And in worst case, you can always just make the prime like ridiculously big, and it gets so big and it overwhelms the minimum number of computation steps, right? So however many computation steps the LLM has during a forward pass, you just make the prime big enough that you can prove that primality testing takes more steps than that. Okay, anyway, I'm making this a little bit complicated, but my whole point is just blurting out a single yes or no in your first token without having more tokens to think is obviously not always going to get you a good answer, right? If you go up to Einstein and you ask Einstein like this really complicated math question or policy question, whatever it is, and you're like, okay, Einstein, you have 3 seconds to answer, 3, 2, 1. You're going to get like a better than random answer, right? Like whatever Einstein blurts out, at least he's injected his intuition into it, but you're not going to get a thoughtful answer, right? Einstein could never figure out the theory of relativity if you keep resetting his brain to a certain state before he'd done a bunch of work on it. And you said, okay, Einstein, figure out how the speed of light can be constant in every reference frame. 3, 2, 1, time's up. Right? Like he needs time to think, right? Even if you're like, hey, Einstein, give me the first token that's going to be in your research paper of the theory of relativity. 3, 2, 1, go. No, I mean, clearly the nature of thinking is that it reflects back on previous thoughts, right? So you need to create a structure of thought as you think. So it's a priori obvious that LLMs aren't going to be super insightful in just their first token, right? So the much more interesting question is, hey, if we give them a couple thousand tokens to think, right? That's kind of the equivalent of giving a human like an hour of time and a piece of scratch paper, right? And yes, the piece of scratch paper is finite. I know this is like a big sticking point for Keith Duggar. Like, yes, you don't get more scratch paper than exists in the pages of the books in the Library of Congress, right? Like you just have to use a realistic amount of scratch paper, which has never stopped a human before, the need to use a realistic amount of scratch paper. But yeah, so if you just give the LLM a realistic amount of scratch paper and tell it to think and tell it to take an hour, that's where the interesting thinking happens, right? I can tell you, speaking personally, there's very few moments in my life where I've needed more than an hour with scratch paper of like hard thinking to come up with an insight, right? I'm sure it's happened like a few times, but it's very rare. I don't think it's happened in the last year. So if we're just talking about computational properties, right, and provable lower bounds of models of computation, it's just a non-issue, right? Like an LLM just has enough tokens during chain of thought prompting or whatever it is. Like there's enough computation here. That's not going to be the ceiling that stops LLMs from being smart. They may have a different ceiling, like, their ability to reflect on themselves. There may be some other limitation that prevents them from thinking effectively, but it's not lower bound on computation steps. Okay, anyway, what is Rao saying here?
There's actually a paper, I forget who the authors were, who said, let's pause. Let's actually put pause tokens in LLM, hoping that then that way it will start reasoning, because constant time, it can't possibly be reasoning. So you just make it pause and maybe somehow reasoning will occur. That's like totally magical thinking.
What's wrong with that logic? How's it magical thinking? When you output a pause token, yeah, you don't have the advantage of outputting chain of thought. So you don't get to read over your own thoughts and use that to build up to the next thought. Okay, so you're not getting that part of the benefit of chain of thought, but you're still getting the part of the benefit where you get to make another pass through all the layers of your neural network, right? The way each token comes one after the other. And every time you make a pass, you're propagating the different weights of these vectors of various stages, right? You've got a lot of matrices. I mean, look, I'm not an expert on these details, right? But you get to run like the attention blocks all over again and the current state of your vectors, like where they've landed in this high dimensional space. They get to influence each other and they get to make these different types of queries on each other and take the result of the query and like project that into some result space, right? I mean, I'm just regurgitating what I've learned about LLMs, but the point is computation is happening. Like you're letting more computation happen when you're injecting a pause token. So Rao is just kind of dismissing that logic, but the way he explained the logic sounds like perfectly good logic.
There is a very different question of can transformer networks Turing complete? I tend to argue that that's an orthogonal question. You can make it. In fact, remember, there were neural Turing machines beforehand, and you can actually, transformers with external memory can be made Turing complete.
Right. And this is all trivial. Like this question about whether they're Turing complete or whether they can deal with arbitrarily large pieces of memory, like the answer is obviously yes. This isn't interesting. Sorry, Keith Duggar. This is like totally barking up the wrong tree if you're looking for a way to analyze these in a productive way.
But the real question, there are variations that people have talked about, but the real question is, I think that's not actually impacting how LLMs are, generating the next token, essentially. It's not like they're actually doing Turing computation of any kind. They're just basically picking the next token in constant time. They're n-gram models.
Wait, what? What? Logic Cop here. Sir, can I please take a look at your podcast? We got a report of somebody saying that large language models are not actually doing Turing computation of any kind. Can I see how he elaborated on that? He said they're basically picking the next token in constant time and they're n-gram models. What's the logical connection here, sir? Yeah, doesn't look good. I mean, when you've got this big algorithm, the large language model inference algorithm, and it's passing through one token at a time, and each time it's outputting a token of chain of thought. And it can keep going and until it reaches a stop token, but there's no fixed constraint to how long it can reason, right? And then it can have a memory, and it can explain jokes, or like solve problems, or propose candidate proofs, or candidate conjectures, and it's doing all this stuff. You don't get to say that it's not actually doing Turing computation. Like it is very much doing Turing computation. That's not a high bar to clear, right? That's a ridiculous accusation to make against it with really no logical argument to back it up. And then to add icing on the cake, he goes and adds that they're just n-gram models when he himself established at the beginning that no, it would be way too big of a lookup table to actually have an n-gram model where n equals 1,000. And also, how can you use an n-gram model when the n-grams in the prompt are things you've never seen before? So how are you going to do statistics on things you've never seen before, right? So he disproved his own claim at the beginning of the podcast and he never resuscitated it. And for that reason, this has been Logic Cop. In this next segment, Rao gives a useful clarification about what he's claiming about what LLMs can do versus what AI systems as a whole can or can't do.
I do question this issue of later models will do everything. The real question is, if you're saying the later models offer different architecture than autoregressive LLMs, I have no reason to disagree with you because the world is wide. I mean, there's just so many different things you can do. And we never said AI cannot do reasoning. AI systems do exist that do reasoning. Like, for example, AlphaGo does reasoning. It's an RL systems do reasoning, planning systems do reasoning, etc. But LLMs are a broad and shallow type of AI systems. They're much better for creativity than for reasoning tasks. And if you just keep increasing the parameters and the size of the system, I have no rational reason to believe that they can do reasoning. They may be able to convert reasoning into retrieval for larger subclass, and that may be practically enough
This is a useful clarification because Rao is setting himself up into a position where he can explain pretty much any capability that's going to come down the line. So if scaling up an LLM lets it just solve any puzzle really quickly without using Python, right? It can just be its own Python interpreter. Like you can imagine like, oh, here's my chain of thought. I'm just executing my own Python program step by step without literally using Python. I'm just using my brain as Python, right? So any workaround that larger LLMs do to just single-handedly solve any problem, Rao is already getting himself set up to explain that because he said, well, maybe they can convert reasoning into retrieval. So like they're just doing retrieval that tells them like what they should do next. And it's not really reasoning, but they've converted it into reasoning. So they've solved the problem and then they've destroyed the world, right? So Rao is already prepared to explain that. He maybe doesn't fully expect it, but he's not denying that that might happen. And he's also been very clear that he's not denying, okay, yeah, maybe you can attach an LLM to some other system like a Python interpreter. And yes, the LLM will do a lot of the heavy lifting, even though he's just, downplaying it. It's just doing unconstrained generation according to him. But like I said, Rao is basically allowing any possible outcome of AIs getting extremely powerful and ending the world. Rao would still be like, I'm not wrong. I didn't say they couldn't do that, right? I just said that they couldn't reason. So at this point in the conversation, I'm not really interested to have a semantic slap fight with Rao about what reasoning is. I mean, I told you my preferred definition, which is to just look at optimization power, look at what kind of input-output mappings it's capable of manifesting, it's capable of navigating, right? Look at what kind of power it has to make things happen or to know what needs to happen in order to make things happen, right? That's my own preferred definition. And of course, Rao's preferred definition, I guess, is more like, well, it has to look more like what I'm used to from good old-fashioned AI. I don't even know what his definition is, I guess. And I don't really care anymore because any input-output behavior is something that falls within what Rao thinks might happen in the future. And my motivation here is to just point out, hey, the increasing power of AI is what makes us doomed, right? And so I don't even think at this point Rao is claiming to be like, don't worry, we're not doomed because AI can't reason. I think he is retreating into semantics, being like, yeah, okay, we might be doomed, but AI still can't reason. Right? I don't want to speak for him, right? This is just my guess. I'm not entirely sure how he would respond to this kind of line of questioning, but I'm ready to say, okay, let's put to bed this question of can AIs reason? I don't think we're going to squeeze any more juice out of it between me and Rao. Let's see what other points Rao is going to make to finish this up.
If they're doing reasoning, then I shouldn't be able to come up with any diagonalization arguments of the kind that I was talking about earlier, such as, changing the names of the predicates or looking at other offsets for the Caesar cipher test, etc. I don't see that going to change just by increasing the size of the models.
Actually, this is a claim where we can make it falsifiable, and we could probably find a prediction where Rao and I disagree on what's about to happen when we scale up the models. Because I'm seeing a trend where if you go from GPT-3 to GPT-4 or Claude 3.5 Sonnet, you are actually seeing these models become more robust. So I can tweak the input in more ways and they don't get fooled. They still do get fooled by some tweaks, but it's pretty clearly fewer tweaks. I'm pretty convinced of that. So I'm ready to extrapolate and be like, hey, I bet they'll be even more robust and, and fewer things will throw them off. But Rao is basically saying, no, I'm pretty convinced that there will always be small tweaks I can make that throw them off. And that's an interesting prediction. I mean, it doesn't necessarily prevent them from taking over the world. I mean, you can have a mind that's like kind of glitchy that can't fully fix itself, but is getting enough reinforcement from like the surrounding environment or from like having some other system check its work, right? Like a domain specialized math solver system or whatever it is. So even if Rao's correct that LLMs can never like robustly check their own work and they can always kind of be fooled, I think Rao and I both agree, well, there's still some other LLM plus X system, which is very powerful and dangerous. But I would love to have Rao come down with the prediction of like, okay, what do you think literally the GPT-5 chatbot can't do? Can you write down right now? Can you give us a hash, give us a cryptographic hash so you can save the timestamp of your prediction of a specific prompt that you just think is really simple and yet GPT-5 is going to choke on it or some next scale of LLM is going to choke on it. I would love to see that prediction and I might personally want to take the opposite side of that bet. I think that's a great separation of me versus Rao. And it would honestly be the first time I've ever seen Rao put a line in the sand where he's not just willing to retroactively explain anything that's happening. This would be the first time that Rao is sticking his neck out and doing the honorable thing of being like, I know something about what LLMs can do. And that's why I feel like I'm entitled to make this prediction, right? Same challenge I've issued to Martin Casado that he managed to wriggle his way out of by saying that he can't tell you which data it's going to have access to. Therefore, he doesn't owe us any predictions. I would love for Rao to find a way to not wriggle out of that and to actually make a prediction, because he seems to come off like somebody with a knowledge state that should enable him to make a prediction. So, ball's in your court, Rao. Let's make a prediction. Let's bet. Let's disagree. I think that would be a high quality discourse. That would be a great way for gentlemen to actually make progress toward resolving a disagreement.
We actually play this game where whenever there's a new bigger LLM that comes out, we do the same PlanBench experiments on them. And as of we haven't yet done the Llama 3.1 that just came yesterday, but pretty much everything basically dies on the obfuscated blocks world problem, for example.
Okay, great. So he has this measure called PlanBench. I see there's a research paper for it. It has examples, and every time a new LLM comes out, he tests it. And I guess he's implying that he predicts that LLMs, because of their nature as n-gram models, according to him, they're just never going to solve PlanBench, I think is the claim he's making, or that's the vibe I'm getting from him. So that's great if he wants to formalize that as a falsifiable prediction, like, hey, my PlanBench test, you're just never going to have something whose architecture looks like an LLM that's going to solve PlanBench. Now, I took a look at PlanBench, and it has some prompts that are like medium length, like, I don't know, a couple pages of prompting. They seem like the kind of thing that Claude 3.5 Sonnet is quite good at, like the kind of thing that I'd expect it to get right. But it's going to be interesting for me to understand exactly why is it not getting it right. Like, they just seem like maybe larger versions of the simple blocks world problem that I showed you in this episode. It would be great if Rao could just post a walkthrough of like, hey, I tried PlanBench and this is where it choked. Because I would love to debug why is it choking, right? It seems if it does choke on these kind of problems, it seems like it's really on the border of getting it right. So maybe we can just put a stake in the ground where I say like, it's so close to getting this right. Like, I bet the next one will get it right. And Rao says, oh, no. It's not close to getting this right at all. It's not robust. So to his credit, he does have a paper on it, although I wasn't able to ascertain from skimming. I didn't come away from my skim with good insight about where it's failing on PlanBench. So I'd love to get more guidance from him. A quick Google, I'm just not seeing a lot of results on PlanBench. So maybe the viewers could educate me, like teach me why Claude 3.5 Sonnet can't do blocks world, okay? Because from my perspective, it seems like it's got a pretty good handle on easier versions of blocks world. So educate me. Let's make a falsifiable prediction. Let's have something productive come out of this podcast. And I'm open-minded that maybe I'll even learn something. Maybe I'll even change my own prediction based on seeing some evidence. Let's see. Finally, we have Rao opining on agentic systems.
On the agentic systems, first of all, I'm like bewildered by the whole agentic hype, because people confuse acting versus with planning. Okay, and my comeback to that is, you leave a gun in a house with a toddler, the toddler would act, but they're not planning necessarily. So that's why we shouldn't have guns.
That's actually not a planning versus agency distinction. That's actually more of a statement about where the optimization power is. So if you learn that a mom got shot in the arm, most of the optimization of that event happened in the design of the gun, right? The improbability of being able to get a bullet that quickly into her arm. It mostly just happened when somebody was architecting, the gunpowder and the chamber, and only a little bit of optimization, and really was unintentional optimization unless the toddler had a scheme. But there's pretty much zero optimization happening when the toddler picked up the gun and fired it. So from an optimization analysis, yeah, the gun maker did the deed. But from a planning versus agency analysis, nobody had a plan, right? The plan is non-existent. So I don't know if this is supporting the point he wants to make, where planning does more work than agency. It's interesting that he chose this particular example.
Conversely, the fact that you can pick up something, or you can press any little button, or you can make function calls, doesn't guarantee that those function calls will actually lead to desirable outcomes. So most people in agentic systems essentially are just somehow thinking that if you can call the function, everything will be fine. That's only true in highly ergodic worlds, where pretty much any sequence will none of the sequences will fail. So it's the only kinds of cases where planning almost is not needed. That's when you can basically get by. But otherwise, agentic systems require, in addition to planning, the ability to call functions.
I thought Rao was going to make a similar kind of point that I make about planning versus agency. The point that I make is that if you want power, then it comes down to optimization. Optimization comes down to planning. An agency is like a little detail. If you've got the plan, you're going to figure out somebody to go do the plan for you, right? Like if you're a super intelligent AI living inside the internet, you're going to bribe somebody to go do what you need them to do. Like the agency part is trivial, right? Coming up with the idea of who needs to get bribed when. Okay, there's one part where your code says, go call up this API to send an HTTP packet over to this Facebook chat or whatever, right? To tell somebody to do something like that is like a minor detail, right? The interesting part is what happened in the AI's brain to hatch the scheme and then, simultaneously operate all the different tentacle arms of the scheme, at lightning speed and playing people off against each other and building power. Like that's the interesting optimization that's happening. Like the agency part isn't really a separate part. But anyway, that's not what Rao is saying, right? Rao is saying, hey, look, you can have agency without having planning, and agency just means like picking up a gun if you see it. And also you can have planning, but you might not get enough agency for your planning if the world isn't ergodic enough. World isn't ergodic enough, just go bribe somebody, man. You can execute your plans when you bribe somebody to do what you tell them to do. Like it's not that hard. So Rao just has separate points that he wants to make, I guess.
People, obviously would like to have agentic systems, but to the extent, since LLMs can't do planning, I don't expect that anything is going to change unless you can have LLM modulo agentic systems where the plan is kind of guaranteed there and then you do function calls. That's sort of a possible thing. So that's how I look at this particular, generalist versus agentic systems.
I disagree with the claim that LLMs can't do planning. I mean, when you ask an LLM to do all kinds of tasks like, hey, write me an essay arguing for some conclusion X, the ability to structure an essay and have it meet the constraints of like, yep, this essay is in fact an organized argument for that conclusion X. That is what you plan to do. Like, you might not call it planning. You might just call it, oh, it's statistical magic. But the thing that it performs, the type of work that it performs is normally referred to as planning work. You normally think of a planning system being needed to perform it. So if you want to dismiss the type of, feed forward, vector, linear algebra that the LLMs are doing, you want to just dismiss it and count it as not planning. Okay, but it just did something that you would normally do planning for, so you might as well just call it planning. So I really object to him saying LLMs don't do planning. I get that he can argue why the type of planning they do isn't always robust. You can perturb it and then it stops working. Fine. But the kind of problems they help us solve, I strongly believe is accurately describable as planning. So anyway, we'll have to agree to disagree on that because we're coming up to the end here. Okay, that is my comprehensive review of Subbarao Kambhampati on machine learning street talk, talking about his research and why LLMs can't reason, according to him. Overall, the part that really sticks out to me the most is the way he doubles down on his claim that LLMs are just doing n-grams with really no justification whatsoever. I mean, the one time when he made a clear attempt at justification was when he talks about diagonalization, which I think means, hey, we perturb these inputs and we don't get a robust result. I think that's good research to do. Those are good experiments to do. But that's your justification for saying that they're freaking n-grams? Like, that's not rigorous. That's extremely concerning that he's talking like that about LLMs, right? Maybe he can just eliminate that particular turn of phrase from his vocabulary. I mean, it's as bad of a slur as calling them stochastic parrots. Like, really? Really? We're approaching the singularity and you're saying stochastic parrot? You're doubling down on that language? It just makes me question his credibility about other claims that he makes. Now, to be fair, I guess the strongest point that he brings up, I guess, is when he talks about specific research he did, right? So it does sound like he's actually kind of an expert as to how you go perturb an LLM to make it say the wrong thing. Like he's talking about having this benchmark, PlanBench, and he thinks of himself as being like on the forefront of detecting what the next version of the LLM can do. I would love to actually get more detail about that. I specifically marked that as an area where I can have my beliefs updated a little bit. I have actually in the past, a few months ago, gone and looked at some of the examples in some of his PowerPoint presentation. And I was, to be fair, a little bit surprised at how tweaking certain things about the LLM input made it choke. It was, to be fair, worse than I realized. So I had to update on that. But I still maintain that its ability to get things right, like the joke analysis example, like I don't care if tweaking that example makes it choke. Or even if the next 3 jokes I give it, it fails to explain, just the fact that it was so good with that one particular joke is incredible, right? So, and I just don't see enough appreciation when he uses terms like statistical, n-gram, I just don't see a proper understanding and appreciation of how this is possible. And then, of course, when he goes on to claim that like they're not doing real Turing computation, I mean, he just raised some major, major red flags with me, right? And of course, the general attitude where he just doesn't seem to expect much from LLMs. But you know what? That whole thing, the tug-of-war game where he's like retroactively explaining everything, I feel like he kind of owned it when he said, look, I'm actually kind of optimistic about AI in general. I don't want to restrain what I might expect to see from next. So it seems like he kind of owns it, that he's not particularly predicting an AI winter or anything. So if you want to get to a falsifiable prediction, I guess I would dive into PlanBench, right? I'd be like, let's talk about PlanBench. What exactly does PlanBench imply that GPT-5 probably can't do? Let's talk about that, and let's try to make predictions, on opposite sides. Let's try to make a bet. The other thing I'll say about Rao is I think he's a smart guy. I like listening to him talk. I find him pretty easy to understand. He's somebody that I could have a conversation with. So shout out to Rao if you want to come on Doom Debates, if you want to hash this out here in the Lion's Den, if you don't mind a little bit of a debate, please come on. I'd love to have you. I think it'd be a productive discussion. And it's like yet another episode of Machine Learning Street Talk where I disagree with a guest, but there's no denying that they've made a quality piece of content. That's it for this episode of Doom Debates. Please do your part if you support the mission of raising awareness about AI existential risk and raising the quality of discourse. You know how you can help. Share the show, smack that subscribe button, go to doomdebates.com, subscribe to my Substack, and I look forward to seeing everybody next time on Doom Debates.